Señoras y señores, muy buenos días. La Universidad Técnica Particular de Loja agradece su presencia y les da la más cordial bienvenida al Simposio Investigativo Ecuatoriano Alemán, programa RESPECT, encuentro académico que conmemora 30 años de cooperación científica entre la República del Ecuador y la República Federal de Alemania. Este simposio constituye un espacio de diálogo académico de alto nivel, donde investigadores, autoridades universitarias, representantes diplomáticos y organizaciones internacionales comparten conocimientos y reflexionan sobre los avances científicos en el estudio de los ecosistemas tropicales de montaña del sur del Ecuador. Durante 3 décadas, el programa RESPECT ha contribuido de manera significativa al conocimiento científico sobre la biodiversidad andina, el funcionamiento de los ecosistemas y los efectos del cambio climático en los gradientes montañosos. La ciudad de Loja se convierte hoy en un punto de encuentro para la comunidad científica internacional, reafirmando el valor de la cooperación académica entre Ecuador y Alemania para enfrentar los desafíos ambientales del presente y del futuro. Saludamos de manera especial a las autoridades que hoy nos honran con su presencia. Doctor Santiago Acosta Aide, rector de la Universidad Técnica Particular de Loja. Excelentísimo Jens Peter Lotgenherm, embajador de la República Federal de Alemania en el Ecuador, y a su distinguida esposa, Frau Lotgenherm. Alexander Schwepp, agregado cultural de la Embajada de Alemania. Saludamos a los representantes del programa RESPECT. Profesora Nina Farbig, Speaker. Profesor Jörg Bendix, Co-Speaker. Extendemos nuestro saludo a los representantes de la German Research Foundation, DFG, profesora Susan Foitzig, miembro del Senado de la DFG. Maika Teschke, Program Director. Cristina Peters, directora de la oficina de la DFG para América del Sur. Saludamos también la presencia de los representantes de Naturaleza y Cultura Internacional. Matt Clark, Executive Director and President. Renzo Paladines, Chief Conservation Officer. De igual forma, damos la bienvenida a las autoridades académicas de las universidades ecuatorianas participantes. Doctor Francisco Salgado, rector de la Universidad de la SUAY. Doctora Rafaela Anasaloni, directora de investigación de la Universidad de la SUAY. Magíster Andrés Fierro, jefe político del Cantón Loja, en representación de la gobernadora de Loja. Saludamos también a Luis Iván Martínez Dobronsky, director de Evaluación de la Cooperación Internacional del Ministerio de Relaciones Exteriores y Movilidad Humana del Ecuador. A todas las autoridades, investigadores y asistentes, gracias por acompañarnos en esta importante jornada académica. Sean todos bienvenidos. Para dar inicio, invitamos a dirigir unas palabras de bienvenida al doctor Santiago Acosta Aide, rector de la Universidad Técnica Particular de Loja. Adelante, señor rector.
Buenos días a todos. Es un gusto para mí saludar al señor embajador de Alemania, a los representantes de la DFG, a los ponentes que van a participar en este simposio de investigación ecuatoriano alemán, al rector de la Universidad de la SUAY, doctor Salgado, a los investigadores alemanes, ecuatorianos que van a dar contenido a este simposio. Es ya un simposio que creo que marca un hito en la historia de la investigación, por lo menos en el sur del Ecuador. Recuerdo haber participado en algunos de ellos, saludando, dando la bienvenida, y sin duda alguna hay toda una historia de cooperación detrás de este simposio entre Alemania y Ecuador, con la contribución invalorable de la DFG y la cooperación entre universidades alemanas y ecuatorianas. Estoy seguro de que este simposio va a seguir contribuyendo al conocimiento del medio ambiente, de las problemáticas y de los temas que se vienen abordando por parte de los investigadores que intervienen en los proyectos de investigación que hay en marcha, y que esta contribución a la ciencia ojalá se vaya manteniendo en el tiempo. Para la UTPL es realmente un honor volver a ser sede de este simposio. Esperemos que sea un lugar para conocernos mejor. Ayer tuvimos una cena muy agradable con el embajador, los representantes de la DFG, algunos ponentes. Creo que esta es la parte complementaria del trabajo científico, la parte humana, conocernos mejor, entablar amistad. Decía que para la UTPL es un gran honor acoger este simposio. Siéntanse, por favor, en casa. Haremos todo lo posible para que la experiencia de intervenir y de participar en este simposio sea siempre inolvidable para ustedes. Y recuerden que la UTPL está siempre abierta a los amigos y cooperadores. Estoy seguro de que el simposio va a ser un éxito desde el punto de vista académico y que sin duda alguna pedirá más, ¿no? Volveremos a encontrarnos aquí para futuros simposios y desde luego para continuar con nuestra cooperación y estrechando los lazos de amistad y de trabajo entre nuestras instituciones. Así que bienvenidos y muchas gracias.
Agradecemos al doctor Santiago Acosta por sus palabras de bienvenida y por reafirmar el compromiso de la Universidad Técnica Particular de Loja con la investigación científica, la cooperación internacional y el fortalecimiento del conocimiento académico. A continuación, invitamos a compartir unas palabras a Matt Clark, Executive Director and President de Naturaleza y Cultura Internacional. Please, Mr. Clark, go ahead.
Buenos días con todos y todas. Hello, everyone. It's my incredible privilege and pleasure to be one of the people opening this wonderful symposium. I want to start by thanking you, Mr. Ambassador. I was going to say your last name, but I thought then everyone was going to laugh at me, so I'm not going to do that. But it's a real honor that you're here today, so thank you very much. I would like to extend a few welcomes, special welcomes. First to the representatives of the DFG, national and local authorities who are with us here today. Thank you for being here. To the rectors and scientific researchers from many prestigious Ecuadorian and German universities. Any university students who are here with us today, very, very welcome. I'm glad you're here. And then finally to members of the Respect Program. We are here today to celebrate the 30th anniversary of a remarkable scientific research partnership between German and Ecuadorian universities and to hear about some very, very interesting research. I'm looking forward to it very much. This research has been generously financed by DFG, which is Germany's largest research funding organization for sciences and humanities, for those of you who did not know that. As you will hear today, the impact of this research partnership in terms of the amount of quality research that has been produced it's incredible. I'm always floored by the amount of research that's been produced. So congratulations to all the many researchers who have produced such important research. And I would say that this is research that has helped my organization, Nature and Culture International, in our work. It's been very important to the work that we do. For those of you who don't know us, I'd like to briefly introduce Nature and Culture International. We are an international NGO dedicated to the conservation of tropical ecosystems. And we began our vida institucional, as you say in Spanish, with the construction of the San Francisco Research Station. So we are the owners of the research station and operate this with for the German and Ecuadorian researchers, and we're very proud to exist in that role. We, over 30 years, so we actually began with a partnership, a small partnership. I think it actually was a partnership of 3 people. One German, one Ecuadorian, and one North American, 30 years ago, and we are proud to have grown now to have a presence in 5 countries in Latin America. So really important for me and special to acknowledge that and acknowledge that it all started with the research station. So I will close by saying that we at Nature and Culture are very proud that it all started here in Loja and with this special partnership. We are grateful for this partnership, and we are fully committed and looking forward to the next 30 years. So let's move into the next 30 years, and thank you again and welcome.
Thank you, Mr. Clark, for this important presentation. Seguidamente invitamos a la profesora Susan Foitzig, miembro del Senado de la German Research Foundation. Please, Dr. Susan, go ahead.
Dear Excellency Jens Lütgenherm, so I try it with the name, directors of the Ecuadorian universities here in Loja and in Cuenca, dear distinguished colleagues and participants of the Ecuadorian universities and research institutions from Germany and from Ecuador, obviously, and dear Matt Clark. So now I try a word in Spanish. So, estimadas señoras y estimados señores, it's a great pleasure for me to open today's Status Symposium, Respect Research Group on behalf of the DFG. I have just returned from a very impressive several-day excursions and visited the research station in the Rio San Francisco Valley, which was established in 1997 by the NCI Foundation as a first research infrastructure so that researchers could collect data on biodiversity in the mountain forests from there. And I was really impressed by the research station and also by the infrastructure built up over the last years, including the climate observatories, the towers, which we found in every forest we visited. And I was also impressed by the researchers which are able to climb these towers. To put this aside, I was really impressed by the biodiversity, especially in the plants, which are a bit more visible maybe, but at the different elevations, we really saw a fantastic biodiversity and a lot of changes in biodiversity. So it really deeply impressed me. I had also the opportunity to talk to many of you during the visit. This visit, the discussion and the program of the symposium beginning today once make clear to me how important this long-term reliable scientific cooperation really is. What has been built here over the last decades is anything but a sure thing. Continuous funding, among other things, the DFG's research group program, but also through international and Ecuadorian partners, made it possible for you to pursue your research questions not selectively, but continuously and systematically over a long period of time. Long-term data collection and stable research funding are essential for the understanding of the effect of climate and land use changes on ecosystems. Only then changes can be identified, classified, and evaluated. The fact that the third research group is now in its third funding phase on this topic, supported by the DFG, is proof of the relevance of your research. The results are not only academically significant, but also provide important and concrete foundations for political actions, such as sustainable ecosystem management, particularly in the current funding phase. And there is another aspect that I think it's worthwhile highlighting. Right from the start, you created structures to train early career researchers from Ecuador and Germany together in these projects. This shows once again how enriching and effective international cooperation can be. I would like to congratulate the research group and all the researchers involved in this outstanding work, which you have accomplished over the past decades with curiosity, commitment, and persistence. And I'm now curious to hear about the presentations on various projects and very much hope to gain deeper insights into your research. Thank you very much for your invitation, and I hope we will all enjoy an interesting event. Muchas gracias y les deseo un evento muy fructífero. Thank you.
Thank you, Dr. Susan, for your exposition. Invitamos ahora a dirigir unas palabras a Su Excelencia Jens Peter Lotgenherm, embajador de la República Federal de Alemania en el Ecuador. Your Excellency, please come forward. The floor is yours.
Dr. Santiago Costa, President of the Universidad Técnica Particular de Loja. Muchas gracias por invitar a nosotros y dar la oportunidad de celebrar este simposio de 2 días en esta maravillosa universidad. I will switch to English. I understand the lingua franca of this symposium. Mr. Matt Clark, Executive Director of Nature and Culture International, NCI. Professor Dr. Susanne Freuzig, Member of the Senate of the German Research Foundation, DFG. Professor Dr. Nina Fawig, Speaker of the RESPECT Research Group. And all the other distinguished representatives of Ecuadorian and German universities and research institutions, students, damas y caballeros presentes hoy en día. A very good day, and I hope a successful symposium to all of you. It is a pleasure and honor to participate in the opening of the status symposium of the RESPECT Research Group here in Loja. The visit of the delegation of the German Research Foundation, DFG, marks a special date in the scientific relations between Germany and Ecuador. Over nearly 3 decades, the DFG has supported outstanding research initiatives in southern Ecuador and on the Galapagos Islands. What has developed during this time is far more than a series of projects. It is a durable, trust-based scientific partnership between Germany and Ecuador, one that combines academic excellence with long-term institutional development. The research group RESPECT exemplifies this commitment, working in and around the Podocarpus National Park and at the research station San Francisco. The group has built an exceptional empirical foundation for understanding how climate change and land use transformation affect biodiversity and ecosystem functioning. The DFG research group format is designed precisely for such ambitious undertakings. It brings together multiple leading researchers to address a shared, strategically defined research question over a medium-term horizon. Frequently, it establishes new scientific directions and strengthens structural cooperation, as we see here in Ecuador. The fact that RESPECT is now in its 3rd funding phase is a strong endorsement of this scientific quality and relevance. What makes the current phase particularly significant is its integrative ambition. Fundamental research is being connected directly to applied ecosystem management. This is highly relevant, not only academically, but also socially. Biodiversity hotspots such as southern Ecuador are of global importance. Understanding ecosystem resistance, functional diversity, and biotic interactions under changing environmental conditions is essential for developing sustainable land use portfolios and informed environmental policy. Equally important is the strong Ecuadorian partnership at the core of this initiative. Cooperation with the Universidad Nacional de Loja, the Universidad Técnica Particular de Loja, the National Biodiversity Institute INABIO, and NGO Naturaleza y Cultura Internacional, and the Meteorological Service INAMI demonstrates that this is not an external research activity, but a genuinely shared scientific endeavor. In this context, I would like to emphasize the structural dimension of this collaboration. Beyond generating knowledge, the research group has contributed to capacity building and institutional strengthening. Numerous Ecuadorian doctoral candidates, students, and interns have participated in these projects. Many of them now hold important positions in academia, public administration, and environmental governance. This is a powerful testament to the long-term impact of sustained international cooperation. At a time when environmental change poses complex global challenges, partnerships like this one are indispensable. They are built on mutual respect, scientific rigor, and shared responsibility. And they demonstrate how diplomacy and science can complement one another, strengthening bilateral relations while contributing to global public goods. I would like to express my sincere appreciation to all researchers involved, to the DFG for its continuous support, and to our Ecuadorian partners for their openness and commitment. I wish you a stimulating and productive symposium, insightful discussions, and continued success in advancing our understanding of these extraordinary access systems. Thank you very much.
Thank you so much for your great presentation, Your Excellency. Finalmente invitamos a la profesora Nina Farbig, representante del programa RESPECT. Dr. Farbig, please go ahead.
Muchas gracias. Buenos días a todos. I also switched to English because my Spanish is not so good. So, dear rectors of the universities of Loja and Cuenca, dear executive director of NCI, Matt Clark, dear senator of the DFG, Susanne Feuzig, dear ambassador of Germany, Jens-Peter Lütgenherr, dear colleagues and friends. It's really a great pleasure and honor for me to welcome you all on this anniversary symposium marking 30 years of German-Ecuadorian cooperative research along Andean gradients, environmental changes in biodiversity hotspots in southern Ecuador. It's a really success. 30 years of collaboration. We will hear a brief overview of this just in a minute from Jörg Bendix, who has been part of this endeavor almost from the beginning. And then later on today, we will hear perspectives of different people that participated along this whole journey. I myself visited Ecuador just roughly a decade ago, and I was totally impressed and exciting that we have such a great environment, trust here in Ecuador. So I could start from the beginning on a very fruitful environment, and jointly with Ecuadorian cooperation partners and students from Germany and Ecuador, we jointly brought new success stories, I would say, in science and beyond. And you can see also later that many of these academic careers that kind of developed throughout the 30 years are now going to present during the symposium today or tomorrow. Moreover, of course, Matt Clark has highlighted this already. The cooperation with local partners of NCI is an asset for this success, and it's also important to get our research finding across. I think also later today we will have kind of presentations of a book and a seed guide, which kind of are essential also to bring knowledge into the public and to foster knowledge on biodiversity in general. So that's really this knowledge transfer is essential. In general, I would like to express my sincere thanks to all our cooperation partners for the fruitful cooperation so far, and look forward to continuing our collaboration. It's truly a pleasure to work with all of you. And I would like to express my special thanks to UTPL and NCI for making this joint anniversary possible. You're hosting the symposium, and you kind of supported us while us being in Germany to making all the preparations here possible. And I want to highlight particularly the continuous support of Balthasar from UTPL and Felipe Serrano from NCI, and of course many others, but the two are the ones where we had most conversations with. I'm now looking forward to the upcoming program and wish us all an enriching symposium with interesting presentations, discussions, and exchange. Muchas gracias. And now it's my great pleasure to introduce Jörg Bendix to you, who will kick off the symposium by presenting the history of German-Ecuadorian research cooperation here in Ecuador. Jörg, the floor is yours.
On the screen. So. Yeah. Okay, we need it on the screen.
Okay, maybe I add that now we have a first block of presentations that will be kick-started by Jörg Bendix, and then we will have a coffee break. So now we get the history, and then we get kind of information on different projects from the Respect unit. Jörg, the floor is yours.
Thank you very much, Nina. Esteemed rectors of the South Ecuadorian universities, esteemed ambassador, friends from NCI, dear colleagues, dear ladies and gentlemen. So it's a great honor to start to guide you through a journey of 30 years of joint research of the history of the German-Ecuadorian research, collaborative research. Yeah, and as we have already heard, when it began, it was in 1997, you can see here, and if you are looking onto the literature of that year, so you can see that people were getting aware that there is a changing ecology of the tropical forests due to global change, climate change, environmental change, and also that especially species of biodiversity hotspots are obviously threatened. But it was not clear how that worked all over the world. So there were a lot of questions how the species are threatened by land use change, climate change, what was the loss of diversity, change of functioning, a lot of big questions which had to be answered. And on the other hand, so we have a lot of tropical hotspots, and we know that the Andes here, the tropical Andes are, we can say, one of the hottest biodiversity hotspots in the world. And at that time, so there were no DFG project in the ecology domain which are really tackling this question. So that was very interesting. So going back to Ecuador, so we already heard, so there was an entrepreneur from San Diego, Ivan Gaylor, who went 1994 into Ecuador and bought a piece of land. And that land was this part, bordering to the Potocapos National Park, which is called the Reserva Biosfera San Francisco. But after a while, he didn't know exactly what I should do with this piece of land. And then he met by chance Rainer Bussmann from the University of Bayreuth, and then thought about that it would be possible really to conduct research to answer these pressing questions of the 1997s. Yeah, and then there were some creative heads here, Arvin Beck, the former president, rector Romero of the UTPL, Ms. Schönwitz from DFG, and others later, so the Palladines brothers, Renzo, Bruno and Pedro. So they discussed what would be possible. And there was an agreement if, so NCI or Ivan Gaylor at that time would supporting some infrastructure to the area. So then the German Research Foundation could imagine so that a research project could be launched in this respect. And that was, of course, the birth of NCI, which also is celebrating the 30th anniversary together with us. So that is a great story, a great success story over the years. And of course, the infrastructure, you always know, was then the Estación Científica San Francisco, which was set up, you see here how it worked, in 1997, and it was ready when the DFG project was approved, so that the first researchers could really start working. Yeah, and you can see we have a long list now, 30 years of research, DFG research, you see here what happened, and I will briefly guide you through something until the latest research unit RESPECT, which will be then introduced by Nina. So what you can see is here that we started with this bundle project. Then we could approve a first research unit 402, and you can see with 25 sub-projects that was possible at that time at DFG. It's not anymore possible today. So then we were able to continue with a second research unit, 816, again also with 25 sub-projects, and you see a lot of side activities combining with EU projects, other DFG projects, knowledge transfer projects, projects to support Ecuadorian PhD students and so on. I will come back later. So that was a very busy part. And then we had the opportunity to apply for a bundle transfer project. So bundle project of knowledge transfer project that was a platform for biodiversity ecosystem monitoring and research in southern Ecuador. And after that, we are very happy so that we could start the now running RESPECT unit 2730. And yeah, we have to thank DFG, because over the years you can say that approximately DFG invested 45 million euros of funding us and the Ecuadorian University, but also we have to thank CENICIT, because in one part, the platform project, they also added funds of approximately $4 million for some of the Ecuadorian platform projects. What happens in southern Ecuador? So that is also a development of our research area. So as you can see here, we started, or the bundle project started very small in the RBSF area, a little bit extension to the San Francisco catchment, and they were really focused on natural ecology, forest ecology. And in the two research units, we extended our study area to a larger elevation gradient, 1,000 to 3,000 meter, and included a land use gradient so that we could compare natural forest to anthropogenic replacement systems like forest plantations and pastures. And then we could complete finally our altitude gradient, because we just reached 3,000 meters here, with extending to the north a little bit to Cuenca, so where we have also the Cajas Paramu as our third area. And we introduced already in the platform project a climate gradient, because we have differences in seasonality in the mountain rainforest and in the western part. So we included the dry forest. And that all culminated in the RESPECT research unit, where you can see that we are now fully integrating the climate and elevation gradients of the mountain rain and mountain dry forest. And that we not only are working plot-wise, but also try to come to area-wide analysis and also results. So let me now go really briefly through what we have done and what was the reasoning of the projects. So the first bundle projects, when they came, so the biodiversity was completely unexplored. As also the abiotic condition, they were not known, so which means that an inventory was urgently needed. And that is, of course, what was the main outcome of the first bundle project, so biodiversity checklists and other inventories. Very successful, very much new species which could be discovered here in this area. And we also started to increase our infrastructure. So we have already heard it by initializing a long-term network of automatic weather stations. That's the ECSF station, which is operating since 1997 continuously. So delivering continuous data, which is very important. So then the following research unit 402, so when the inventory was done, so the big question was, of course, how the species or these components of the ecosystem interacts. That was species species and species-abiotic interactions, which are also unknown in this area. And so also how the ecosystem really functions in comparison also to the replacement systems, mainly the pastures, that was also introduced. And the major outcomes was, of course, that we could describe all of that. Again, we could increase our infrastructure with the help of NCI. We could extend the ECSF station, a lab extension building. We could install a first rain radar on the Cerro del Consuelo, but we also supported the local universities out of the research unit. Just some example from the National University, for instance, there was constructed a greenhouse for the cultivation of indigenous tree species, which could be used for the rehabilitation of abandoned pastures, which is still operating today also as a company. Second example from the UTPL, and it is just a selection. So the research unit supported to establish, for instance, the first molecular biology lab facility here, which was brought forward by Juan Pablo Suarez, and also a science lab, a soil science lab, which was brought forward by Hernan Lucero at that time. So then came this research unit 816, which was a very busy time in our joint activities. So here we had the focus that we wanted to understand first time how climate change, land use change is really impacting the ecosystems, because that was also not known at that time. And the major goal and the major outcome should be to develop a science-directed land use portfolio, which at the same time preserves the high biodiversity of the area and the services needed for human well-being. And we also restructured a little bit our research approach, because that was the first time in the history of our research that we established a joint plot system in this area along our gradients. So it was the first time that we conducted ecological experiments to learn how this impacts global change impact worked. And it was also the first time where we started with integrative land surface modeling to assess the ecosystem services of our gradient of the forest. And again, with help of NCI, we were very happy that our infrastructure could be further developed. So from this building we had in the research unit 402 to with a new building, the lecture hall building, which was added then in the research unit 816. And of course, I already stressed the experiments. I just can't go through all these experiments, but one long-time experiment is very important in the natural forest. That is a nutrient manipulation experiment, NUMEX, and we also on the pasture system, we had some repastorization and pasture afforestation experiments. Yeah, so, but we had a lot of side events in this research unit 816. One point was data. Data is very important today in research, but it was not a topic at the beginning in 1997. There was no database. So it got be a bit more pressingly important in the research unit 402, where we developed the first database. And then it was really pressing in 4816, because there it was clear that the data has to be available, also of reuse for later generations of scientists. And so we were needed to develop a project database following the FAIR principle with a DOE certified open source working database. And the research unit also was very active in data management policy of DFG. So we conducted the first symposium on data repositories in environmental science together with the Biodiversity Exploratories and the Senate Commission of Biodiversity Research of the DFG. Out of that, we had some pre-studies then from the Senate Commission, which finally led to the GFBio data management and the national data infrastructure for biodiversity. So at that time, we also get a deeper discussion with our counterparts, because we know that DFG is mainly funding German researchers and German institutions, and the Ecuadorian PIs wanted to contribute more equally with own ideas, but no funding was available at that time in Ecuador. And we are very happy that at that time we get the solution also with the help of DFG, that was Dr. Halm from the international department, to launch a special side program to the research unit. That was a bilateral cooperation with South Ecuadorian universities in ecosystem research, and parallel to the research, and we could here launch 12 PhD student projects established, which the principle was that the Ecuadorian PhD applied for own scientific projects in the scope of the research unit. The funds for the PhDs comes from the university research funds, and DFG pays cooperative stays of these PhDs in Germany at the partner project of the research unit. And the aim was already to try to come or to pave the way for a real national co-funding with CENESID at that time, which was not possible at that time. Funnily or happily, I can say we had a very high-ranked visit at our station, a DFG delegation, which was led by DFG President, Professor Kleiner. And that was really very interesting, because there we had then negotiations with CENESID. And what was the outcome was very astonishing. So we got really a cooperation agreement between DFG and CENESID signed. And you can see that was focused on funding joint research projects with regard to basic research. Example was biodiversity research, the first example, and that both parties are willing to co-fund and co-review so the research of the Ecuadorian or of the German part. A second novelty also in our research unit 816 was that we could launch transfer projects, so to transfer the knowledge out of the research unit 816. And that was a tool at DFG at that time which was more or less only used for CRCs in engineering in Germany. So you have a product, develop a new car, and then you can buy a prototype with something like that. And we were allowed to apply as for the first two transfer projects outside Germany, and with cooperation partners which were not from industry but also from administration and co-design, co-production. And you can see here one of this was to bring the afforestation efforts into practical applications. There was Nueva Bosques para Ecuador, the program. And the second one was, of course, from our experiences of the radar climatology, that we could form the radar network SUR with the universities and with partners, provincial government, Etapa, city enterprises of Cuenca, with FORAGUA, and also with our cooperating partners. And finally also Piura, University of Piura, joined our network a little bit later. So that means we had paved the way for co-funding, and we had paved the way for knowledge transfer, and that was a starting point of the platform project, of the biodiversity platform, because there was an urgent need at that time for knowledge transfer in the country. We had a lot of good basic science, and so we decided to apply also a very special construction, a bundle project of knowledge transfer, which was, I can say, legally very complex, because we had to make contracts between all universities and all partners with across the national legal systems. I can imagine that was no fun, but it worked at the end. So, and we wanted to develop two prototypes, and it was developing a sustainable land use system, and the second was monitoring system for ecosystem functions as an early warning system for the country and for its biodiversity and ecosystem function. Yeah, and we had this co-production, co-design, and co-funding, of course, and for that we formed an initiator group, you can see, of all contributing institutions. We had the first meeting at Senckenberg Museum of Natural History in Frankfurt, and then follow-up meetings in Cuenca and Quito in the ministry, and also here, of course, in Loja. So then we had really the co-funding process, where we had the Ecuadorian parts of the platform with a review by CENESID, supported by DFG, and the review round of German platform projects of DFG, and happily that was approved so that we could come to co-production, and that was be done at that time by regular workshops to develop the two prototypes and to implement the two prototypes here at the universities and with our stakeholders. And again, because we were extending to the dry forest, as I said in the beginning, we were very happy that NCI could support us again, because they already had this nice station, Laipuna Dry Forest Station, but it was too small, of course, for this platform project. And they agreed so that we could have a new Cabana building, which was already set up, and also extended our infrastructure. And last but not least, we have already heard about the towers from Susanne. So we started tower building at that time, because in the second prototype, in the monitoring prototype, we were focusing also on water and carbon fluxes and upscaling that from the plot to the area. And for that, we needed sophisticated measurements at the tower. At that time, it was scintillometry. And yeah, we have seen, meanwhile, in respect, and Nina will surely talk about that, or the others, we have meanwhile erected 7 canopy towers, and 2 are today equipped with eddy covariant systems, and 1 we have also with the canopy walkway. So that's also great infrastructure. Of course, publications are that is a currency of science. You can see. And that is, of course, so the period until the end of the platform. We have issued a lot of publications, and we are very proud that more than 40% are really first or co-authored, increasing level meanwhile by Ecuadorian researchers. And also we have collected a huge amount of data sets. That is a used figure, so I get out the data bank. So we have more than 50 million data values on long-tail data, and big raster data. We have collected more than 2.5 terabytes from our model and remote sensing data at the moment. One important point, we were very much devoted to ABS, access and benefit sharing. And what you can see here is the early career researchers we have supported over the years in our research unit. That is again the period until 2016, including all programs, but also we added a lot of DA, DK, D Prometeo stipends, and so on. And you can see we graduated more than 200 thesistas, approximately 150 PhDs at that time, and a lot of postdocs. And again, if you are thinking in an ABS category, you see that it's almost half German and Ecuadorian. So there are some others, but these others are, of course, also mostly from other Latin American countries here. And that has an impact on the research, or had an impact and still have an impact on the local research environment. So you can see that are the career paths of former PhDs in our programs, and many of them are sitting here. And we have already seen, we have very much success stories like Nicolai Aguirre, rector of UNL, or Professor Juan Pablo Suarez, which is the former rector for research at UTPL. And yeah, I could go further, and that is not the final list, so that's just a selection. That shows that there is a big impact of our joint research also for this science environment in southern Ecuador. But so that was the scientific word, and we also wanted to use our data for nature protection. That is also the mission of NCI. And NCI is a major national actor here, or was a major national actor in applying for UNESCO biosphere reserves to protect the areas. And this needs scientific information. So we always, with our programs, provided scientific informations and concepts for this biosphere reserve. And together with NCI, so that could be successfully launched in the period 3 of this UNESCO biosphere reserve. That was Podocarpus El Condor, Marquiso del Cajas, and Bosque Secos. That is also a great success with regard to ABS and nature protection. Yeah, and summing this up, so we can say that we were very much into this ABS process, so members of the research unit and also of NCI, and so were attending the ABS open-ended working group of the Rio Convention on biological diversity, and are leading in writing these things in Cali, Colombia here. And we had, of course, a DFG site event together with DFG head office, where we introduced together our success story here on the Biodiversity Science and Policy Forum at UNESCO at the headquarters in Paris. Yeah, so with this, I guess unfortunately, I have to stop because I could tell a lot of more stories, but the time is over. And so I guess the take home, what we already have heard in the first speeches, is that we can say that we have a globally unique research infrastructure here set up in tropical high mountain forests. We have meanwhile an unparalleled treasure trove of data for tropical mountain forests and biodiversity hotspots. It's very important for especially the long-term perspective of 30 years, because long-term data series are really needed for global change research, because it's slow, of course, in the time scale. Yeah, you have seen we are deeply integrated into the local and regional scientific environment. And here, again, I have to thank our cooperating universities, UTPL, UNL, University of Cuenca, and UDA, which without their help, so we was able to develop everything and conduct everything. And last but not least, of course, this intensive knowledge transfer to all relevant stakeholders. And that was only possible with the help or with the cooperation of NCI. And NCI, I guess I would say, Matt, that's our family meanwhile. And it's exciting and I would say unique to have 30 years of continuous, reliable cooperation. I guess that you can't find that many examples all over the world. Yeah, and as you said, the next 30 years, of course, many questions are left open. That's in basic science. You never can answer everything. And we are, of course, looking forward to develop something so that we can come to a follow-up. My last slide, and then I'm done. Thank you very much to DFG. We have seen that was a tremendous amount of money which DFG investigated in environmental research. And so that is now going forward. It's not only RESPECT, but we have this new research unit reassembly, which will be introduced by the spokesperson, Nico, later on. And we have the small collaborative project in Galapagos, which is also funded by DFG. And with this, we have really a great gradient. I'm climatologist. If we are talking about El Niño Southern Oscillation, you know, we are on the core of ENSO. Then we have the impacts on the western slopes, which has a completely different seasonality. And then we have the informations from the eastern slopes and from the highlands. And I guess I see a lot of synergies in future. And with this, I thank you very much. And I hope I was not too long, and I would directly hand over to Nina, which then goes in the most recent decade to the RESPECT unit, RESPECT.
Okay, thank you very much for this nice history introduction. And now I want to present or introduce the currently running research unit RESPECT, which is entitled Environmental Changes in Biodiversity Hotspot Ecosystems of Southern Ecuador, Response and Feedback Effects. When we started RESPECT, climate change was already going on and people were talking about increasing temperature or changes in precipitation patterns. But what we can see also here is that their extreme events are increasing. And Jörg has mentioned the ENSO already and records of albedo, for instance, in 2023. And the long-term data that has been highlighted by Jörg already is that we also can show in the mountain rainforest, but similarly for the rainforest also, that we have a lot of anomalies in precipitation, for instance. So tropical forests are severely threatened by environmental changes, and these comprise not only climate change, but also land use change. For instance, these data show the observed deforestations from 2015 to 2020, and then also based on the trajectories, the deforestation projections for the future. So as there is demand for land, of course, also some forests are still cut, and yeah, so the aim is also to find sustainable solutions for that. We are not a biodiversity hotspot, so we don't know all species yet. So one approach is to use a trait-based approach, which can allow us to better understand which species are lost first and how communities change. So for instance, we could look how current communities look like or they have been changed over some years, or elevation and gradients, which species persist and which communities persist, and which traits are available or represented in these communities. And these are kind of the response traits that respond to environmental change. And then we can also look at the traits that are important for interactions, for instance here in herbivory or pollination or seed dispersal. And with this we can learn about ecosystem functionality, and these are then the so-called effect traits. And with this response effect trait framework, we can try to get a better, or at least a little bit of a mechanistic understanding of how communities respond to environmental change and how future communities might look like if environmental change continues. And then, it has been highlighted already, we can use models and integrate these trait data into models to project the resistance of ecosystems to future change. For instance, also ecosystem services, how they might respond. And models have shown that, for instance, if you just look at net primary productivity in temperate systems, that already high diversity ecosystems have a much stronger resistance than low diversity systems that decrease much more in their productivity if extreme events take place. Yet in tropical ecosystems, this is hardly understood. And on top of this, we also don't know how the interactions between the biosphere and the atmosphere and the soil systems take place. And that was kind of when we started RESPECT, and our aim was to understand it, or to at least contribute to shedding light on that. So when we started, our overall objectives was to unveil how ecosystem biomass production, so particularly carbon storage and water fluxes, are affected by climate and land use change, and to integrate more biodiversity into these land surface models. So what we did was, first of all, intensive field sampling across our core plot system that has been touched by Jörg already, then to use the response effect framework to understand how the biota are changing and also the functions are changing. Then these are still implemented into land surface models that are biodiversified meanwhile. And then Jörg has mentioned this already, we try to get into the area and then upscaling from the plot system. This has been shown already, so we work across a long environmental gradient from the dry forest to the rainforest with strong gradients from 600 to more than 3,000 meters. We have differences in temperature and precipitation, also seasonality. This allows us then also to tackle and project how potential shifts will take place if the climate shifts. Some selected key results are that, for instance, from the early 98 onwards, also depositions patterns of bulk and also the nutrients are monitored over time, and you see that over the time we find an increase in bulk deposition, particularly also nitrogen that increases. We monitored many different tree species, and you can see that particularly with decreasing N availability across the mountain rainforest into the upper slopes, we have also a shift in the trait spectrum. So we have fast acquisitive plant species here where we have a high availability of N, and we have a low conservative slow growth where we have a low availability of nitrogen in the systems. While we are still sorting some of our data and preparing the last, particularly invertebrate databases, we also teamed up with another research unit funded by the DFG at Mount Kilimanjaro and looked how different functions in terms of biomass stocks and process rates are affected by biodiversity. And we found almost both in the Andes and at Mount Kilimanjaro that both species richness here on the left side and also variation in species richness, in the dark green, and species turnover, so the beta diversity component, are both positively affecting ecosystem functions. So biodiversity matters, and it's not only the number of species but also the identity that matters, and that's why the traits can help us here. And then, this is a very dense picture, and Thomas Hickler can explain it much better later on in detail, the modeling part, but what has been achieved already during the first phase of RESPECT is to integrate trait data, particularly of the tree communities, above ground, for instance, specific leaf area, and with specific gravity, but also root traits of the trees into these dynamic models, and then they are run and kind of serve as an experiment. You can see over time which species survive along the different environmental gradient, and at the beginning, we wanted to start with plant functional types, but in the end, kind of because of the wealth of data that had been collected in Ecuador along the time, we could even implement trait data of all the trees and could improve the projections because we had also reference data over time to see, for instance, how trees grow and how carbon is stored there. Then also all the nutrient data and even below ground traits, the roots I have mentioned then already were integrated into the systems, and even the biomass production above ground was much improved in the models. And in a second step, Thomas and Matthäus also included interactions, so if herbivory is present in the systems or not, influenced the projections of the model, and could also highlight that this is contributing to the high biodiversity and better diversity in the systems. Then we want to upscale the data. So we took data on the leaves, so with spectrometers, and then looked, for instance, how the observed specific leaf area that was measured on a leaf itself was linked to the predicted specific leaf area of the measurements from the spectrometer, and as the overlap was, or the relationships, correlation was pretty good, it was possible then to upscale specific leaf area, for instance, but also other measures across the area, and this will also be used in the current synthesis phase to kind of come from the plot to the catchment and beyond scale. And I mentioned it, and Jörg has mentioned it before, it's of course also important to understand how decisions of communities then either lead to an increase in forests or a decrease in forest availability across systems. And for that we have Thomas Knoke with us in the project, who kind of use different land use scenarios that are then either optimizing the biodiversity side or the economic side. And there we can see that if you have a conservation-prone scenario, then we can also see that projections in the future will increase forest coverage across the area. Okay, and now, since almost a year, we are in our synthesis phase, and I will only touch this briefly because the different project will be introduced by different people now. So we have the first synthesis project, which kind of tests the resistance of past ENSO and future climate change optimized projections, and also is linked to the socioeconomic scenarios. The second one is particularly kind of integrating our model from the plot scale to the global scale, or catchment and then global scale, and look at the carbon storage and the water fluxes towards climate and land use change. Then we have two projects working rather on the trait side. The first one particularly on tree communities and how trait coordination shape forest dynamics and in respect to climate change. And the second one integrates the trait variation across different taxa to see how these affect processes and the resistance of these forest ecosystems. So in brief, we have a space for time approach where we work along the elevation and gradients. We have an extremes for time approach where we have, along the long history of data, also extremes in the past that can help us to project in the future, and these are all then integrated in future scenarios to understand how the resistance of these ecosystems might change with environmental change. So for the trait composition, we assume, for instance, that if we have fast acquisitive species, we have also a rate in the ecosystem that is fast. So if we have fast-growing tree species, we'll have also a fast turnover of carbon storage, while if we have we have communities with very slow and conservative traits, then also, for instance, carbon storage is taking much longer. And this is one result that Jürgen has particularly contributed. So it's all tree species that have been collected so far across the gradients, where you see on the first axis the slow to fast gradient here. So these are all the tree species on this side which are growing slow, while these are all the ones that grow fast. And on the second axis you have kind of also an efficient versus a safe strategy. So leaf properties and wood properties determine the trait space of trees. And you can see in brief, Jürgen will explain it in more detail, that we have a shift of this slow, fast, efficient, safe across the gradient from 1,000 across 2,000 to 3,000 meters in the mountain rainforest. So in the extremes or very harsh climatic conditions in Cajanuma, we have rather the slow-growing species, and in the lower end of the gradient, the fast ones. And in Laipuna, you also see another shift in the trait space, also rather in the middle, and also in the middle of this efficient to safe gradient. And I touched this already. We linked then the traits with the environment across different trophic levels, from trees up to birds as insectivorous predators, and see that kind of we find a correlation between the environment and the traits, particularly strong for trees, and getting lower for the higher trophic levels, which shows that particularly the trees that are responding to the abiotic climate are more sensitive to environmental changes. And we see that this is a consistent effect, that particularly here on the left side, where we have the primary producers that are mostly linked and more efficient in the high temperatures with low precipitation and higher soil fertility. And on the other side, we have also the precipitation that increases here on the higher elevations, where we then have both contributing climate, or temperature and climate to this trait environment coordination. And also here you see that temperature and precipitation is most important for the different taxa, but soil fertility matters particularly for trees and also a bit for ants. Then for the ecosystem change projections, as a short introduction, we aim to use two scenarios, the SSP 4.5 and the one 8.5, and we want to project for 2050 and 2100. And on the one hand, we want to understand how trait diversity contributes to the resistance, and we will for that compare always kind of the current systems of our current ecosystems to optimized land scenarios, which are the green ones here on the side, both for the mountain rainforest and for the mountain dry forest. And this will then allow us to test how climate change and land use change, and also their interactions, contribute to the resistance of the two forest types. And again, we have, first of all, to calibrate models. We have here the calibration for pastures and forests in the mountain rainforest, and you see that the measured and the modeled, both latent and sensible heat flux, are pretty much show a pretty good correlations. And with this, we can also project in the future how sensible heat flux and latent heat flux are responding, at least here until 2050 and 2100. So while the one is rather a bit stable, the latent heat flux will increase in the future. And this is kind of the short summary of this, that the resistance of latent heat flux and sensible heat flux are going to decrease here in the mountain rainforest, while they increase in the mountain dry forest, and it's a bit the opposite pattern for the sensible heat flux. And Paulina will go into detail on this much more. And this is one of my final slides. You see here over time with this eddy covariance system that kind of measures also the exchange between the biosphere and the atmosphere, how the carbon is stored, and whether forests and in the rainforest and in the dry forest are rather carbon sinks or carbon sources. And you can see that both systems are carbon sinks, but as you can see, the mountain rainforest is much more a carbon sink, while the dry forest has kind of a balance in the dry season. Then it's kind of emission and storage of carbon is relatively similar. And it's roughly the rainforest, roughly a double carbon sink compared to the dry forest. And then we are also interested in how kind of burning in the Amazon affects nutrient deposition in our mountain dry and rainforest, and how this changes, for instance, specific leaf area and also photosynthesis in the future. And this will be touched by Thomas Hickler in a minute. And last but not least, Thomas Knoko can explain this better, and we'll do it in a minute. We use these different scenarios, whether we kind of use the land more intensively and exclude any afforestation, then of course we have an increase in forest loss, while if we have a lot of money for conservation payments and conserving and protecting our forests, we have the opposite. So we will have an increase in forest area, which is kind of very intuitive. But what we see here is that if we consider multifunctionality, we always have node shift, because then there's a demand for wood, of course, but also if we then consider vascular plant species, which is another biodiversity component, then we can get an increase in forest coverage, and like this also communicate to the public and to the governments which solutions and which trade-offs they have to face when conserving biodiversity. So in a nutshell, we worked particularly in the first phase of RESPECT in the mountain rainforest, in the second one in the mountain dry forest, and collected our data there. And now we are in the synthesis phase, where we will bring all our knowledge together. And we are a big consortium of many people from different universities, from different subjects, from both particularly Ecuador and Germany. And with this, I would like to thank you and hand over to Paulina, who will present SynA1, particularly the first part, climate and flux observations and remote sensing. Thank you very much.
So good morning, everyone. My name is Paulina, and today I will talk about part of the results within the SynA1 subproject. The SynA1 contribution to the research unit emphasizes observations, remote sensing, plot-based modeling, and land use scenarios optimization. The work is organized within 4 working packages. In the first working package, we focus on the observations. Here, we use field measurements to estimate how the ecosystem processes will respond to the ENSO extremes over time. The second working package uses remote sensing techniques to estimate the spatial patterns of the processes and extremes over larger areas. In the third working package, we applied plot-based modeling to look how the ecosystem processes will develop under climate change in the future. And in the last working package, we look at the optimization of land use scenarios. In my talk, I will concentrate on the third working package and up-to-date results. My focus will be on the mountain rainforest, which I will compare with the pasture ecosystems. The target function I concentrate on is the latent heat flux. Latent heat flux is associated with evapotranspiration processes, including evaporation from soil surfaces and transpiration from vegetation. These processes consume energy and are often associated with the cooling of the surface. To analyze these processes under climate change, we conducted simulations until the year 2100, and after that, we estimated the resistance of the target function. The model used was the Humboldt-TD model. This model is a plot-based framework which was developed in the second phase of the RESPECT project. The model is designed to simulate interactions between vegetation, soil processes, and atmospheric conditions. The workflow consisted of several steps. First, we needed to prepare the model forcing parameters. For the time period 2000 until 2025, we used the data which we measured in our climate stations. For the time period 2026 until 2100, we used climate projections. After that, we calibrated the model by using the field measurements from these 2019 until 2022. After the calibration, we were able to apply the model for the whole time period of 2000 until 2100. And lastly, we estimated the resistance of our target function, the latent heat flux. Our model needs several parameters for the forcings. These included air temperature, relative humidity, wind speed, wind direction, air pressure, precipitation, as well as incoming and outgoing shortwave and longwave radiation. The time span needed was 2000 until 2100, and for this we needed a continuous time series of data without any gaps. The spatial resolution the model needs was 50 meters, and the temporal resolution was 30 minutes. So I will start with the climate station data. The observational data often include gaps which had to be filled before running the model. This was done by using the interpolation method and considering spatial relationships between the stations, such as elevation and distance. The figures here show an example for the temperature and precipitation for the period until 2025 for the three sites, Bombuscaro, Cajanuma, and San Francisco. The climate projections for the years 2026 until 2100 were derived from the CMIP6 scenarios. We used an ensemble of 5 most suitable models for these regions. Like for this, we can then acquire the uncertainties which come up with using projection data. Additionally to this, we used 2 scenarios. Firstly, the SSP2 4.5 scenario, which is associated with intermediate greenhouse emissions. And then the SSP2 8.5 scenario, which is associated with high emissions. However, the climate projections have a spatial resolution of 45 kilometers, and the values are available are only daily mean, min, and max. To get the models at the spatial and temporal resolution needed for our model, we conducted 2 kinds of downscaling: spatial downscaling and temporal downscaling. For the spatial downscaling, we adapted the delta method. There was a 10-year period of time where the measured data and the projections overlap. For this time period, we calculated the daily mean difference between the measurements and the projections, the delta, which tells us how much the projections overestimate or underestimate the climate values. After that, we could apply the delta to downscale the projection data. For the temporal downscaling, we used the encoder-decoder machine learning framework. This framework learns the relationship between measured daily mean, between the daily mean, max, and mean values, and the sub-hourly pattern in the course of the day. After that, we can predict or reconstruct this sub-hourly pattern also for our projections. Now, having the parameters set for the whole time period, we had to calibrate the model. The model was calibrated separately for forest and pasture ecosystem. The calibration was done against 4 parameters: shortwave and longwave outgoing radiation, our target function latent heat flux, and the sensible heat flux. So here you can see the results of the calibrations. The results are showed separately for pasture and forest, and the metrics used were R-squared, RMSE, and MAE. The R-square was above 0.96 for both forest and pasture sites, and also the RMSE and MAE values are relatively low, which means that the overall deviation was relatively small. Here are the results for the sensible heat and the latent heat. The model performance for the sensible heat was relatively strong. However, for a latent heat flux, the agreement was somewhat weaker. This was to expected because the model yet cannot model the energy balance closure sufficiently. After calibrating the model, we could then run it for the whole time period until the year 2100. Here you can see the time period on the X scale and the value of the latent heat flux on the Y scale. The different colors show the scenarios. The green color is the intermediate scenario, SP 4.5, and the red line is the high emission scenario, 8.5. The shaded areas are the variants of the ensemble models. In the course of the years, both of the scenarios show a decreasing trend of the latent heat flux. The trend is between 0.3 and 0.4 watts per meter per decade, and the results are statistically significant. This means that less evapotranspiration will be counted for in the future. And now for the sensible heat flux. In contrast to the latent heat flux, we can expect an increase of the sensible heat. The trend is 0.5 until 0.6 for both scenarios, and the results are as well statistically significant. These results suggest that a larger fraction of the available energy may be transferred to the atmosphere as sensible heat. This indicates a potential shift in the partitioning of surface energy under future climate conditions. Now we can look at the pasture. Firstly, for the latent heat flux. In contrast to forest, in the pasture we can see a slight increase of latent heat flux of 0.3 watts per meters per decade for both scenarios. Again, the results are statistically significant. However, for the sensible heat, we see very small trend or no trend at all for both of the scenarios, and for the scenario of 8.5, the results are not statistically significant. This indicates that the sensible heat flux in pasture systems remains relatively stable over time despite changing climate conditions. In contrast to the forest ecosystems, pasture systems therefore do not show a strong shift in energy partitioning between latent and sensible heat. Now we can estimate the resistance of our target function, latent heat flux. The resistance in our study is calculated as the ratio between the values in the future, concretely in the years 2050 and 2100, and the values within the reference baseline period until 2025. If the values are around 0, this means that the resistance does not change under climate change. If the values are positive, this means that the resistance will increase in the future, and if the values are negative, this means that the resistance will decrease in the future. Looking at the forest areas, we see that for latent heat flux, the resistance tends to decrease under both scenarios. Several mechanisms may explain this pattern. Firstly, increasing temperature and changes in precipitation patterns may reduce soil moisture availability, which can limit evapotranspiration. Another factor may be physiological responses of the vegetation. Under warmer and potentially drier conditions, plants may reduce transpiration by closing their stomata in order to conserve water. When we look on the pasture, we see a contrasting resistance values. We see that the resistance for pasture, for the latent heat flux, will increase in the future. One explanation for this could be the different structure between the vegetation in the pasture and in the forest. The vegetation in the pasture is generally less complex than in the forest. The grasses may also respond more rapidly for the changing conditions and increase water uptake when the water is available. However, now we can look at the second image. Here we see not the relative changes of resistance, but the absolute values of the latent heat flux compared between forest and pasture. We see that despite the decreasing trend of the latent heat flux in the future, the absolute values in the forest are still twice as high in the forest than in the pasture. For our future work, we will analyze this more in detail and also conduct the model analysis for diverse other land use scenarios. Thank you very much.
Thank you, Paulina. Now we have first the other Thomas, not Hickler, but Knoke. So I introduce Thomas Knoke while he's coming up and load the presentation, who will inform us in more detail on the socioeconomic scenarios. No, it should work.
Okay. Good morning, ladies and gentlemen, dear colleagues, dear students, should there be some. I will talk about land use, a little bit also about economics, and you can realize if it comes to economics, first people are leaving the room. But you are here, and I'm very grateful that you are. I'm a colleague of Carla. She is also in charge of the project, and we partner with Jörg, Katja, and Paulina in the same project. My motivation is to better understand mechanisms behind deforestation and also, in the best case, to contribute reducing deforestation. The underlying idea is that the landscape's composition is in charge of costs and benefits of the landscape. So, for example, if the people prefer financial return or liquidity, labor requirements, or also the people's preferences, then it is likely that they would shape the landscapes in a direction that these costs and benefits are improved. And that could lead to a declining proportion of the natural forest. You see the proportions here on the vertical axis, and the time axis is the x-axis. If we can model these processes, this could help us to explain past, current, and predict future deforestation in our both study ecosystems. I would like to discuss two topics. First, I would like to show how we can use the models to test whether forest conservation in the past has worked. And second, also very important, we will try to identify which factors drive deforestation and how we can improve or reduce deforestation. Don't be scared, I will start at the global level, but I will end up in the ecosystems we have studied here. So, looking at the effectiveness of forest conservation requires us to measure something which we can't observe, because we must measure the deforestation that did not happen. I try to illustrate this with the figure where changes in the deforestation rates from 2000 to 2023 are shown. The black line is remotely sensed changes in deforestation rates, and this yellowish line here, that is our model prediction. The model assumes that the people would just look on the land use profits. So we took data which is published by the FAO, market data, and then we modeled how we would have expected the people to shape the landscapes and to deforest. And we see that this expected deforestation here increases twice as much as the observed deforestation. And we are confident that the delta here is because of successful forest conservation initiatives. This differs a lot across the continents. We see here Latin America, we have increasing pressure on the forest but declining deforestation. But look at Africa. In Africa, deforestation is escalating even more than we would expect. And in Asia, both the expected deforestation and remotely sensed deforestation are decreasing. For us, most important is Latin America. We should not be too enthusiastic about the results because the improvements, reductions in deforestation are limited to only 6 countries, which you see here in the greenish color. The pale green, there no conservation has been achieved. So out of 28 countries we analyzed, only 6 contributed to reductions in deforestation. What is most important to see is that Ecuador is among those countries, and we know this because Balthasar Calvas has analyzed this nicely. But now, after this excursion to the global and continental scales, I would come down to the study regions which we have analyzed here as part of the research unit. But this shows that we can apply the models we have developed here in Ecuador also beyond the borders of Ecuador. So here I would start with the mountain rainforest and show you one example of land use trajectories, which is quite extreme. You see the change in the landscape composition, which is indicated here over time, and that leads to a reduction in principle, we lose 2/3 of the natural forest because we assumed here that the farmers depend only on the livelihoods of pasturing. So no alternative income options are given. If we now make use of this really nice research on restoration of abandoned lands here inside the San Francisco Valley, we would have options like pine plantation and native alnus plantations and pasture restoration. So if we would include those options actively, then we can save more forests. There's still deforestation, but we can save at the end 30% and not only 17% of the natural forest. This will be our baseline for the next analysis, because here we show how different factors would contribute either to reducing forest losses, that are the green bars, or increasing forest losses, that are the red bars. We see conservation payments would work. What was exciting for me was that we could also analyze a lot of ecological indicators which we could define as benefits. So here in this research, considering multifunctionality, we considered 23 ecological and socioeconomic indicators. And that led to the result that we could not save forests indirectly by just including a lot of ecological functions, because a natural forest cannot fulfill all these functions. So we need more land use options. If we want to achieve conservation, then we must directly address what we want to conserve, that is here biodiversity. If we this include as an indicator, we can achieve forest protection. We see also a link to environmental changes, which are later reported, for example, by Thomas Hickler. We have obtained here N deposition, and we assumed that with increasing N, productivity would also increase, and that would make that we would lose more forests. Higher productivity would enhance the pressure on the natural forest. However, we do not just predict this in percentage values. Thanks to the work of Kala, we are also enabled to make spatially explicit modeling. You see, Kala has tested 3 scenarios considering only farmer benefits and regulating services, and farmer benefits and biodiversity benefits. And we see, so with a little bit of fantasy, that only in this scenario we have a reduction in deforestation. Those scenarios would not differ. Also very important, we work also in the dry forest, where Jonathan Torres has studied how should the landscape look in future when multifunctionality is the objective. That is the current distribution, mainly silvopasture, a little bit corn, a little bit other agroforestry types. In the future, those types, shaded cocoa and shaded coffee, should be expanded to have better multifunctionality on the cost of the current silvopastoral systems. We have to dive deeper in whether this is really desirable or not, because these systems are now in competition to the classical system, but that is also forestry based, so maybe it's not too bad. Yeah, that is what I wanted to tell you, and the conclusions are that these multidisciplinary research opportunities I had here really changed my scientific life, and I'm really grateful that I could work in this group since 2007 already. So I showed that these land change models can facilitate policy impact analysis, so whether conservation worked or not, and finding strategies to mitigate deforestation. Improved land use and conservation payments could improve the situation a lot. For a more detailed look in spatially explicit modeling, I refer you to the talk of Carla, so it would be obligatory to you to listen to her tomorrow. And with this, I thank you that you stayed in the room and listened to me, and I'm at the end. Thanks a lot.
Yeah, thank you very much, Thomas. Now we switch to the other Thomas, Thomas Hickler. And I apologize that I didn't allow questions, but we are a bit behind schedule. That's why we thought we postpone them to the poster session later on. So if you have questions also to talks right now before the coffee break, I thought like this we can kind of get back to the schedule and have the intensive discussions in front of the posters.
Yeah, I will talk about our research to biodiversify a land surface model. So why would we do this? We want to do this because current land surface models, which represent the vegetation of the Earth, also within climate models, they basically ignore biodiversity. Like the whole tropical forest might be represented by one plant type, like a tropical evergreen broadleaf tree. And this is, of course, not sufficient to simulate also the functioning of ecosystems and how resistant they might be to climate change. So now first some general background. We know from many studies, many of them about the Amazon, which is very much in the research focus, that climate change can have very dramatic effects on tropical ecosystems. So what you see here is from one model, also from our research here under 2 climate change scenarios, how much the biomass in the forest could change because of climate change. And you see in some areas a reduction of more than 50%. This is a model, by the way, which also represents biodiversity to some extent, so not just one plant type, but parameterized with global data only. And the different scenarios here, these 4.5 or 8.5 stands for how much watt per square meter extra ends up in the atmosphere because of climate, because of anthropogenic climate change. 4.5 or 8.5 watts per square meter. So very dramatic effects here, which confirm the results of others that the Amazon forest might be a tipping point, or might be close to a tipping point. Now another study where we analyzed different vegetation models and different climate models, and looked at how consistently these models simulate a biome shift, like a shift from a tropical forest to a savanna, for example. And there we see actually that one hotspot of these simulated biome shifts are the tropical Andes, including Ecuador, not the Amazon rainforest in these models, where it remains more or less stable. But again, these global models, of course, they don't represent the unique biodiversity in the mountain rainforest and in the dry forest in our study region here, and you wouldn't trust them for Ecuador. So now, in the RESPECT project, we used the really outstanding and unique 30 years of data from the RESPECT project to parameterize and to adapt a global model to the ecosystems which we study here. And in the end, we we managed to create a model which simulates the trade shifts here, for example, from the low elevation sites to the upper elevation sites. You see here individual plants, only woody species, the wood-specific gravity, and how it changes against the specific leaf area, and how it differs like at the lower side and the higher side. So for example, at the higher side, you simply have thicker leaves, which are more adapted to a harsher environment and to more nutrient-poor conditions. And on the plot level, the model simulates each individual tree and then how these individuals compete with each other based on their traits. And it can reproduce also the gradient in net primary production, biomass, carbon cycling, and so on. But this has been also presented at earlier meetings here, so I don't go too much into details. And by the way, most of the work I present has been carried out by Mateus Dantas de Paula, the postdoc on the project. He's sitting over there. Maybe you can stand up and wave or so people know who you are. But now to more recent results. Now, first of all, one main result so far has been that the temperature gradient alone cannot explain the shift in plant traits from the lowland to the highland side. The main important factor, according to our model, is actually the nutrient availability. So the temperature influences how much nitrogen is available in the soil, and this is the main driver of the trait shift. And that was a surprising and new result for us. So because nutrients are so important, we focused more on nutrients in other projects. And one thing we looked at is the effects of insect herbivory, with data from Jana Schön, Nina Farbig, and others. Because insect herbivory is known for that it actually can accelerate the nutrient cycle and can make nitrogen and phosphorus more available. So it can have positive effects for the vegetation growth. And this is illustrated here in this figure. It's maybe too complicated for the talk now. But the important thing is that insect herbivory can accelerate the nutrient cycle and maybe have positive effects. Basically because the insects, when they eat biomass and some of the carbon is respired, goes to the atmosphere, and they themselves are basically very decomposable litter compared to very thick leaves. So our hypothesis was that maybe at the high elevation site, which is very much nutrient limited, herbivory could even have positive effects for the productivity. So we took data from our colleagues here, which I just mentioned, on how the leaf consumption here changes with the leaf CP ratio. And it turns out that the herbivores prefer leaves with lots of phosphorus, normally also thinner, softer leaves. We implemented this in a model, not only vegetation model, but also a model for soil, carbon, water, nitrogen, and phosphorus cycle. And then the result was that our hypothesis was totally wrong, which is actually good because we learned something. I mean, just confirming a hypothesis is pretty boring normally. So if the herbivory is switched on, here even the biomass in the forest is actually reduced in the model, and it also is much more consistent with the data which is shown here in gray for the 3 different elevations. So that was kind of surprising for us, and then when analyzing more in detail what's going on here, it became, for example, clear that because the herbivores, the insects, they prefer like the soft leaves with lots of phosphorus, they shift the whole community towards tree species with thicker leaves, which also are less decomposable, so not so good litter. So the herbivores induce like a trait shift in the community, which reduces the decomposability of the litter and the nutrient availability, and then also the productivity of the forest. After that, we got interested, of course, more into roots, because they are important for below-ground processes, and implemented the so-called fungal collaboration gradient, which represents the fact that, some roots, some plants make many fine roots where they can take up the nutrients themselves, and other plants, they let the mycorrhiza, the fungal part of the symbiosis, do all the job. They don't make very fine roots themselves, but instead they pay the mycorrhiza fungi to take up the nutrients. And when this is implemented in the model can simulate the specific root lengths and also to what extent mycorrhiza is used to take up nutrients. And you see if this is switched on in the model here in blue, it corresponds very much with the field data on the specific root lengths. And that we had data on specific root lengths and also how much the mycorrhiza is used by the plants to take up nutrients. I mean, this is really very, very special. You know, as a vegetation modeler, we never had such data along an elevational gradient. So that was very exciting for us. Data from Jürgen Hohmeier here and others. Then we are also very interested in what Nina already mentioned. There is this dramatic increase in nitrogen deposition in this region here. The nitrogen deposition right now at the San Francisco station is more than in Frankfurt, like a metropolitan city where I live in the middle of Europe with like 10 times the human population density. So it's a really, really high nitrogen deposition. Jörg has shown, by the way, the measurement devices to measure this, and Nina has shown the data, how it increases. Some of this increase might indeed be, or is shown to be, from Amazon fires. Here it's shown how the air and the nitrogen is transported from the Amazon into the study region here. And what you see here, according to the model, again, how basically the leaf thickness of the community responds to this increase in nitrogen, like a very dramatic increase. And according to the model, actually, there should already be a shift in the leaf traits in the community going on from species which have more thicker, smaller leaves to softer leaves with more phosphorus and so on. So these ecosystems in reality, these shifts are probably a bit slower than in the model, but the model here can be used as some kind of early warning sign. 3 minutes? Okay. And now we want to also look with satellite data if there are indications that this shift is already going on. And of course, this is not only about leaf traits. I mean, there are species behind this. You know, if this is really happening, it's going to have a dramatic impact on the biodiversity. So now in the synthesis phase, we have started to simulate not only individual sites, but the whole study region, including like the dry forest here at Laipuna. And of course, we will also represent the main land use types in the study region here. And now we already come to the conclusions. Well, first of all, some of the blind spots in land surface models, which are normally ignored, really, really matter in the ecosystems here. Nutrient dynamics are a key driver. Insect herbivory has rather negative effects on the biomass. Productivity, the root traits and mycorrhiza are also important. And finally, the increasing nitrogen availability might be a major threat for the unique biodiversity here. And it's not only about deposition. At the higher side in the mountain rainforest, the increase in temperature is also increasing the nitrogen mineralization because of the warming. Then I just want to shortly mention some other work that we are doing here, but for the sake of time, I cannot go into details. We also have started working on including seed traits and recruitment dynamics, some kind of coupling with the land use change modeling that Thomas Knoke has been showing. An implementation in a real land surface model. That's technical details. But most important, of course, addressing the one final big question. What is the one final big question? That is, if the unique biodiversity here really is increasing the resistance of the mountain rainforest and the dry forest to climate change. And we have some preliminary results on this. Of course, we can use the model for this. We can switch on and off the trait variability. But it's preliminary and we don't trust the results fully. So I will not talk more about this because we don't have the answer yet, unfortunately. But finally, I want to say thanks, in particular to our partners here in Ecuador, who gave us the unique opportunity to work in this wonderful country. It has been truly amazing for me. I learned a lot, and yeah, just thanks for that.
Thank you very much, Thomas. Now we have 2 more talks before the coffee break. I hope you can still bear with us. Jürgen will start on this. And talk about the trees and how they change in growth and structural dynamics in response to environmental change.
Thank you, Nina. Welcome to my talk. I'm going to present you today the sub-project B1. Our project is focusing on trees, tree growth, and forest dynamics. And our sub-project is composed of many people participating. So there is Wolfgang Wilke, one of the co-PIs. He is here, and Achim Bräuning, unfortunately, is not here, and different Ecuadorian universities and institutions. So, yeah, okay. So within our sub-project, we have 3 work packages. The first one, that's the one that is focusing on trees, their strategies, and their functional characteristics. So to see how functional diversity, so the contribution of all tree species within several study sites, are driven by environmental factors. Yeah, the second work package is more related to forest dynamics and tree demographic rates, and so how forest dynamics, everything related to above-ground biomass, above-ground carbon storage, is related to abiotic drivers and also to tree functional diversity. The third one, that's the one, maybe the most interesting one, because it tries to predict how tree communities will respond to future environments and how functional diversity and environmental drivers will be responsible for these changes we expect. So in the next slides, I'm going to present you first very specific results. Everything is preliminary, the latest results from the last month. I will start with the first work package and show you some results on physiology, so starting with photosynthesis. My colleagues, especially Achim Bräuning, Volker Raffelsbauer, and Erwin Beck, they were working on photosynthesis. They compared different tree species at the study sites, and what they found that there in general is no such a big difference in photosynthetic capacity between the study sites in the elevational gradient. So trees at 1,000, 2,000, and 3,000 meters perform at a very similar rate. And if we look at dry forest, there is a strong shift. So first, there is a difference between dry season and rainy season. Clear, there's no photosynthesis if the trees have no leaves. So, but there are different strategies present in dry forest. So we have evergreen trees. And the evergreen trees, they perform, you can see here, that's capacity during the dry season. And that's very similar to the values we find in the rainforest. And so that's the first interesting finding. And then deciduous trees, those trees which don't have leaves during the dry season, but in the short vegetation period during the wet season, they have very, very high capacities, so almost double of the rates we found in the wet forest. So a strong difference between strategies related to photosynthesis. Next result, another one, very specific, physiology, root water uptake. We measured root water uptake in some species in the dry forest. And what we find is, you can see here, that's climate during 1.5 years of study. So the blue bars are precipitation, the dark blue curve, that's soil water content, and that's the performance of the different compared tree species. So you see a difference between the curves, and that's the different strategies of the species. And the most interesting one is, oh no, let's start with the general pattern. So in general, we see that as expected, leaf phenology and also soil moisture, that means water availability, are the main factors driving water uptake in plants. But if we now look a bit more on details, we have here in this figure 2 different curves. So the purple one, that's a deciduous tree species. And as expected here, during the rainy season, you have water uptake. So the peaks here, that means there is water uptake in this tree species. And the yellow curve, it's in cactus. So a cactus species shows a very different strategy. It takes up water during the whole year. If there is rain available during short rain events in the dry season, it immediately takes up water. So quite a very special and adapted strategy for dry forest. But these studies are only possible on very, very few species. So photosynthesis and water uptake, that needs a lot of infrastructure and people to doing it. And the problem or the challenge in our study area is that we have so many different tree species. So what we did, because we cannot measure physiology in all of them, we try to get functional traits which we can relate to function in these trees, and we try to get these functional traits for all species. So you can see here a picture of a permanent plot. All the trees are labeled with specific numbers, and they are measured. So their diameters are recorded several times, and from the diameter measurements, we have an idea on diameter increment, and we calculate relative growth rates. And then we collect leaves and also wood samples to get an idea on leaf properties and also on wood anatomy. For example, in leaves, it's nutrient content and also specific leaf areas. That was already mentioned by Thomas. It's a very important parameter and could be related to photosynthetic capacity. And in wood, you can see here 4 samples from different species, and it's mainly the number of vessels, so these small white dots here, circles here, and the diameter of those vessels. So species with large diameter vessels, they have a high conductivity. And if we put all the informations together, we find we can use them for ordination, and this is a result of a principal component analysis, including more than 500 tree species from all the study sites. And it includes 10 different properties. So the green ones related to leaves, brown is related to stem properties, and here the black one, that is relative growth rate. And you can see here that there is a first axis. So on the right, you have species which are normally fast growing. So here, high values of relative growth rate related to high specific leaf area, high nutrient contents. On the other end, leaves are tough and thick and smaller normally, the slow-growing species. And then there's the second axis, that's mainly wood properties. So from here, very efficient hydraulic properties, high conductivity, and on the other hand, high specific gravity in wood and high vessel density, but small vessels. So we have 2 main axes. And the interesting thing is that we can relate the relative growth rate across all study sites with the acquisitive leaf properties, as one would expect. If we now use the same method to compare the study sites, we see this is all trees together, and we have here the 4 montane rainforests and below the 2 dry forest sites at different elevations. And what we get is a shift in functional strategy along the elevational gradients and also along the drought gradient. So the more humid forests here, the dry forests here, and they occupy different spaces within the functional trait space. And in general, it's interesting to see that at each site there's a large spectrum of different tree strategies present. And especially what was a bit surprising, that here in the dry forest sites we get only few species, but these species occupy a large space. So that's very interesting, that the functional richness is relatively high in in these seasonal dry forests. So, too fast. The next one is related to our second work package, where we try to predict forest dynamics, tree growth, demographic rates of trees from the environment and from functional strategies of the trees. So this is one example for the dry forest, where we used all the available information on traits, on soil, on growth rates for the present species, about 60 tree species. We did several models, and then you can see here the result of the models. And all the colored bars mark factors which are significantly affect tree growth. And yeah, overall, the summary of this graph is that tree diameter is very important. So large trees are growing slower than small ones. Then wood-specific gravity is also important. So the high-density wood species grow slower. And the trait axis, so all species with acquisitive traits, they have faster growth than more conservative tree species. In general, there were some soil effects, but they were comparatively very small. So this is one example. We started with the dry forest, and we will do the same for all forest types to get, in the end, a structural equation model trying to explain the combination of all environmental factors as climate and soil, and also functional traits on tree growth and forest dynamics. I come to the third work package, so the one related to the future, so predicting how will forests and tree species respond to future environmental change. And one very big advantage of our study area that was already mentioned is that you have long-term data, long-term monitoring data. And these two figures show one or two examples for data available from the study sites. The first one, the red figure here, shows the leaching of nitrogen from the organic layer. And you see here an increase. That's a time period of more than 20 years. So it's a unique time series. And the second one is on potassium. And on potassium, you see a contrasting effect. So that means that potassium is increasingly retained in the organic layer and probably is becoming more important for the vegetation. So very important effects on soil nutrient availability that will affect the vegetation. And in addition, I will show you some results of our nutrient manipulation experiment. It started already 17 years ago in 2008, or 18 years ago already, where we continue to add nitrogen, phosphorus, and the combination of both nutrients to mature forest stands. That's a replicated full factorial design at the 3 elevations. And I show you again an ordination graph. So what we did was we collected leaves from the study site at 2,000 meters. Almost 2 years ago, we collected leaves from 400 species within the 4 different treatments and analyzed nutrients. So 9 different nutrients, and you can see here the arrows. Each arrow marks one of the nutrients studied. And this is a whole community at 2,000 meters, so 400 points. And of different tree species. And if you look now in detail on the different treatments, what you can see is that the different treatments occupy different parts of the trait space. So there is an effect of nutrient addition on the functional trait space. That means that the so-called biogeochemical trait space of the tree communities is shifted, or in this case is expanded or displaced by nutrient addition. And there's also the expansion of trait space. That means there is an increase in functional richness, and that is a response to relaxation from nutrient limitation at the study site. And another last slide on results from this nutrient manipulation experiment, that's more related to productivity. So I show you here results on litter collection. We did that for more than 10 years. And we collect monthly or bi-weekly litter samples in all treatments. And the graphs here show you trends in the total litter fall mass and then the nutrient contents, nitrogen and phosphorus contents in the different treatments. In the left column, you see the 1,000 meter side, so there's almost no effect on litter mass and no effect on litter nutrients content. So litter quality is not affected by fertilization. But then at 2,000 and 3,000 meters, there was an effect. And here, looking first at the total litter mass, so total litter collected in the traps, we see that the combined addition of nitrogen and phosphorus affected or increased the mass we collected in the litter traps, but only after some years. So it needed at 2,000 meters almost 7 years to get an effect of fertilization. At 3,000 meters, it was much faster, so after 2 years, we found already an increase in productivity. The nutrient contents were increased after addition of the respective nutrients, and you see here in nitrogen, we find higher contents if we add nitrogen or the combination of both nutrients. The same as in phosphorus. In phosphorus, we find higher nutrient contents if we add phosphorus or the combination of both nutrients. The interesting thing is that in nitrogen, it seems that we get to a certain level of nutrient concentration. It's not increasing anymore, but in phosphorus, it was still increasing. So, to summarize these very preliminary results, we have many tree species that's sometimes a challenge, and they have all different functional strategies. Tree growth across all study sites is related to acquisitive leaf properties, seems to be the main predictor of growth. We have a change in strategies along the environmental gradients. We have this unexpected high functional richness in the dry forest. Long-term monitoring that was mentioned already before, that's very important and that's unique, that we have available these data series from our study site and that we can show that nutrient availability is changing during time. So looking at our manipulation experiment, we can show that tree communities and single tree species are responding to shifts in nutrient availability. So in their biogeochemical niche and overall in the biochemical trade space occupied by the communities in the different treatments, and in productivity, in fine litter mass and quality, we see that there are some effects, and the effects seem to get stronger at higher elevations. So the next step is to combine these results with recent results from re-inventories of our permanent plots to the shown results of the climate group and also of the modeling group to see what will happen in the future, because as Thomas mentioned, that's the most important question, to see how functional diversity maybe is helping to make these communities more resilient. Thank you very much for your attention.
Yeah, thank you, Jürgen. I'm sorry that I'm standing again here, but the postdoc Annemarie Wurz is expecting her second baby soon. That's why she couldn't travel here, and I have to give the presentation. But let's see, the work has been carried out. Now. So the last project I'll present is the B2 synthesis project on community-level trait variation along environmental gradients in a tropical mountain rainforest. And I think you're all well familiar that environmental filtering is driving taxon-specific trait changes. And one famous example is the Bergman rule, where you have kind of here in the tropics very small penguins, while if you go to the Antarctica, they are getting larger and larger, while for plants you find kind of the opposite pattern, that you have larger species at lower montane forests and have smaller ones at the higher montane species, as you have been also seeing along our elevational gradient. So our question is therefore whether environmental filtering is driving coordinated trade shifts. And here's one example from Germany, from the biodiversity exploratories that have been mentioned already, where they work along, for instance, grassland management continuum, where you have here the extensive grasslands and the cultivated grasslands. And what you could see in their joint analysis across taxa is that you have the specialists, large body-sized, slow-growing species on the left side, where you have the extensive management, while if you intensify management in these grasslands ecosystem, you get much more faster species, generalists that are very well in dispersal, have small body sizes and very fast generation times. So this results comes from a managed system. And so far, it's not really clear, on the one hand, whether across anthropogenic gradients you have cross-taxa coordinated responses, and that's why kind of we set out with these wealth of data that we have here in southern Ecuador to understand if community-level trait syndromes exist also across steep climatic gradients here in southern Ecuador. So our question was whether, on the first question is whether there's a relationship between the environment and community-level trait composition. Then secondly, we wanted to understand if there is such a relationship, which environmental drivers are coordinating these trait shifts. And in the last question is whether we have really a syndrome, so whether similar traits across the taxa respond similar to the gradient. So we expected that, according to literature, that traits co-vary with environmental gradients, and we have a stronger shift at the lower trophic levels. That temperature is key drivers, because it has also been shown, for instance, in Matteo's work, that through the nutrients they drive the shift of the tree community, and that we will also see a shift from large fast to small slow strategies with increasing elevation. You have heard where we are working, so I can be a bit faster, so the coffee is not so long ago away from you. So we have this environmental gradient from drier and warmer fertile sites to wetter, colder, nutrient poorer sites at higher elevations. And we sampled trees, birds, and 4 different arthropod taxa, which can be seen here, covering 4 different trophic levels from primary producers up to secondary consumers. And we assessed a wealth of functional traits, both either measured in the field or from databases, for instance, for the birds. And then we set out to use the data that is available from the climatologist and averaged, and that's here. We first averaged and normalized the traits for each species, then combined this with plot-level environmental data on temperature, precipitation, and soil fertility, and in the next step did RLQ analysis, which is a multivariate method where on the one hand you have the environment for each site, you have the species composition for each site, and you have the traits for each site, and you kind of do a covariance analysis to see whether traits respond in a similar direction or respond across the trophic levels to the environment. And this I have shown you briefly already. So we looked how the different traits across the different trophic levels and taxa are related to the environmental gradients, and we see that this relationship across the environmental gradients for taxa like the primary producers, the trees, is highest and is decreasing with trophic level, but not existing also for some taxa in between. That's mainly because also we have little data for those taxa, but generally we found an environmental trait relationship. In a second step, we then looked which environmental drivers are mostly associated with this correlation between the trait and the environment, and that's on the one hand temperature and on the other hand precipitation, but they work in different directions. So if we have a high temperature and if we have a high precipitation, they work or are differently correlated with the primary producers across the trophic levels to the secondary consumers, while soil fertility only mattered for trees, for ants, and for the primary to secondary consumers, so rather the insectivorous and frugivorous birds. Then we were interested is whether there's a trait syndrome, so whether all the different taxa relate to body size to this environmental gradient. And there we found that particularly for trees, we see that the maximum height kind of is associated, what Jürgen has shown already, to warmer temperatures, higher productive systems here at the lower elevations, while we have the kind of smaller trees here on the right side, so across the elevational gradient. You see also for different arthropods, for instance here, for the curculinids, and that the kind of maximum pronotal width is related to this, and also for some bird taxa and the ants, you see a similar shift. So body size is positively related to the environmental gradient, and you see larger taxa across many trophic levels in the more productive, warmer sites. We then looked whether also we find kind of regarding to the resource use a similar relationship to our environmental gradient. And here we only found for the trees a relationship which has been shown and explained by Jürgen already, that you have a strong correlation with the acquisitive traits of the trees, so fast growth, high hydraulic conductivity across this gradient from very productive warm climates to the harsher environments, while for the arthropods and for the vertebrates it was not that important. And largely we were interested whether kind of the mobility is also related to our environmental gradient, and there we saw that for certain taxa, for instance here the staphylinids, you see that apparently the more mobile species are also related to the warmer environments, while for all the other taxa we didn't found trait syndrome related to mobility. So the take-home message should be that we found an environmental trait relationship that is strongest at the lower trophic level, so for the plants, but it also existed across higher trophic levels. Secondly, that particularly temperature and precipitation are the important drivers for these trait environmental relationships, while soil fertility was only important particularly for the plants. And lastly, that only body size kind of was the trait syndrome which explained our trait environmental covariance, and that we have the greater taxa at the lower elevations across all trophic levels. And with this, I want to thank you for your attention and give the credits mostly to Annemarie, who did all the work, while kind of all of the co-PIs with me, Eike, Matthias, and our collaborators, Jürgen, Diego Marin, and David Donoso from Ecuador, of course, contributed a lot of trade data and information. So thanks very much for your attention. And now we have a coffee break, and I hope we can then exchange maybe also some questions. And I'm sorry that I didn't allow questions, but like this, we somehow made it almost in time to the coffee break, and then can have more discussions in the poster later. Thanks very much. Would it be possible for you to come up here, because Balthazar just asked that he would be pleased to have a group photo from everyone up here before you take the coffee, so 2 more minutes, I hope. Okay, stay here. But they are leaving partly. Yes.
"30 years ago, On the Andean slope of Zamora Chinchipe and Loja, a scientific partnership was born, one that would go on to earn international recognition.
Invitamos a todos para hacer una fotografía grupal antes del coffee break acá arriba. Bienvenidos todos.
Research Foundation, developed in close collaboration with universities in Germany and Ecuador, and strategic backing from Nature and Culture International, the program set out with
un aviso, vamos a iniciar después del coffee break 10 minutos más tarde para que tengan tiempo de tomar café y conversar. 10 minutos más tarde.
La una era que entregue Nina. Hola, hola. Hola, hola. Y el otro, hola.
Okay, please reconvene so that we can proceed with our symposium. We are already a little bit behind the time schedule.
Habe ich auch gesagt. Sag ich Ihnen. Ja. Wie ist die Fläche? Jetzt frage ich, ob ich mich mit dem Ambassador und dem Rektor kurz drüben treffe, aber dann verpasse ich die ganze Zeit. Nein, Jörg will do. No, Jörg will do the.
Okay, I guess we can start, so we're a little bit late. And the second block, I would say, is very important because it is about the visions of our cooperating partners, universities, how they see to promote our big topic, biodiversity change and environmental change. And I'm very proud and happy to present the first speaker. So that is Roland Sellery from the University of Cuenca. And Rolando, the floor is yours.
Good morning. Thank you very much for the invitation to participate in this symposium in which we are celebrating these 30 years of collaboration between German universities and Ecuadorian universities. In the case of University of Cuenca, we are celebrating 20 years of cooperation since we came a little bit late to the platform of cooperation here in Loja. So for me, it has been a good opportunity to reflect on these 2 decades of cooperation and to see how things have changed in my university. So in 2007, I had been back in Ecuador. I did my PhD in Belgium, and I was back in the University of Cuenca, and was invited to conform a committee, a think tank, as we called it at the time, to design the university that we wanted to have in the year 2020. And it was because at that time the university was mainly a teaching university. So very little research, only all the structure was oriented to teaching, and we wanted to change that situation. And in this think tank, we identified the key aspects that could make to become a university sustainable in research. And the aspects that we needed are are listed here. So first was human capital, so to have professors with a PhD degree, to have infrastructure with which you could do research, so to have labs, and also field sites from which you can get data, so to learn about the ecosystem functioning. We needed an internal organization, not only based on teaching, but also that is flexible to do research. We needed international and national partnerships with which we can grow our knowledge and to make research more meaningful. We needed graduate programs, which are the basics for doing sustainable research. And we needed to change or to create a research culture, because so far was oriented only to teaching, so it was hard to convince the need to do research at the time. And of course, we needed funding. So I did my PhD in hydrology. I was studying the hydrology of the Paute Basin, which is important for hydropower generation in Ecuador. And at the end of my PhD, I really squeezed all the databases that we had, and I was worried about my own future, my academic future, because I didn't have any information with which I had to do research. But when I was finishing my PhD, I was reflecting on my future career, and I was reading a lot of papers from Ecuador and from the region, and there was one name that was coming always in the best papers that I was reading, and that was Bendix as an author. So I said to myself, I hope one day I can collaborate with him. I would like to grab a beer and to set up some collaboration. And of course, to increase the knowledge in hydrology, it was clear that we needed to understand how the ecosystems work, particularly the Paramo ecosystem. This is a picture from the Paramo for those who are not used to it. And they look like this. So although it's a pristine ecosystem, cold, far from the cities mainly, but you can see that there are many processes going on, like we see in this slide. So there are pine plantations, there are some, the culture is during dry periods, we burn the Paramo. There's also agricultural going on there. And when you take, of course, if you see the rivers, they look quite nice and the water is transparent. But when you take samples, sometimes you find heavy metals and you find some new nutrients and you're wondering what's going on here. So we didn't have that information, and we knew that to increase the knowledge on hydrology, from process-based to water use afterwards, we needed to increase the knowledge on all of these aspects. It was the same with the Andean forest. We know the importance of the relationship between forest and water, and we didn't know anything about that. And I wanted to increase the knowledge on hydrology again. It was highly needed to go into these ecosystems. At that time, I had some friends that had started doing their PhDs, and one of them, I found him when I was back, and he told me, I'm doing my PhD in San Francisco Station. And I didn't know anything about San Francisco so far. And he was Patricio Crespo, and he was doing small-scale hydrology. And it was just what I wanted to do when I was back, so it was great. I was doing large-scale hydrology for Ecuador, and he was doing small-scale hydrology. So, okay, of course, now we can work together. And at that time, the government in Ecuador had changed, and the new government was really investing in research. So there were permanent calls for research projects, and in 2008, we presented a project that got funded. And with this, we set up our first eco-hydrological observatory in the Paramos that is called Shurukai, which since 2009 has been active, and we have permanent monitoring there. So we started measuring discharge with these devices, with sensors. So the information was, finally, very good databases, very precise information regarding water quality, quantity, but also on how vegetation and other processes are interacting. So this is a look at Shurukai. It's only 7 square kilometer catchment. It's a small catchment. We're measuring discharge in all the small tributaries and all the creeks, and also measuring water quality, as I told you. We implemented meteorological monitoring with different range of sensors, some of them very advanced to measure precipitation, like this hydrometer, for instance. And later on, we were able to install an eddy covariance tower and measuring energy fluxes as well. So things were going on well in that first experimental catchment. But it was hard to convince the local institutions to invest in funding because they were thinking Churucay is too small, it's far, it's not in the catchment that is of interest to the drinking water company, for instance. And they said, you need to go to another place. And they said, why don't you come to the Tomebamba catchment because it's the headwaters of the city and we have the drinking water plant over there. So in 2012, we established a new observatory that is called Quinoas Ecohydrological Observatory. Quinoas is the Ecuadorian name for the polylepis tree. So we chose that name. And since that period, we've been monitoring also this catchment. This is a larger catchment, it's 100 square kilometers. The water that is draining from there goes to the drinking water of the city. So we were having a good cooperation now with the drinking water company, with Etapa. So Cuenca is at the bottom left of this slide, and you can see in the upper part, later on we installed a rain radar as part of the cooperation. I will come later about this. So we were starting these observatories, and later on we needed to implement a new dimension that is the vegetation, and we started also working on restoration. And now we have a new restoration ecology observatory that is also distributed in several places nearby our catchments, and we are now gathering the information that was complementary to understand all these relationships between forest, soils, and water. So in these years, we were able to implement all these observatories with sensors, with technology. So we were learning how to do things because many of the sensors were not designed really for high mountain elevations. So it was also learning while doing. And at a given point, we were ready to start a cooperation with several partners. So before that, it was hard to start cooperation because we didn't have the means to do it. And since 2009, we were attending this symposium because Patricio was involved in this, and so he was always inviting us, why don't you go to Loja? And this picture is from 2012. It was one of the first meetings with our colleagues here, and when we decided now we're ready to start a more strong cooperation, really pushing science for the future. So also the importance of this symposium is that is probably the only academic event that we have in the year in which I will not miss. So every year since 2009 we've been coming, and of course we hope we can continue coming in the future. And we started this cooperation more strongly and a very horizontal cooperation. As part of this cooperation, we started receiving some pieces of equipment, like this is an isotopic water analyzer, so we can analyze with this the sources of water. We can know the age of water, if it's water that is coming from rainfall, or it's an old water that was in the catchment for several months or probably years. So we could already relate what part of the catchment is contributing to water in the dry period or also during floods. So now we can really start doing management of the watershed, because I know which part of the landscape are contributing more to the discharge that is receiving the drinking water company, for instance. So we set up this tracer hydrology group, which has been one of the most successful groups in my department. Really, tens of papers have come from this equipment or from this lab that now have grown. We have many more equipments now, and is the backbone of most of the research we are doing in hydrology here. And Patricio is in charge of this. We also started doing some water quality analysis. As I told you, we were worried by heavy metals and by nutrients, and we also had the chance to have these type of sensors with which we are measuring every 5 minutes several parameters of water quality in the rivers, and we can inform the drinking water company, for instance, about the state of the water, the state of the rivers, and in time we can see if there is an evolution in terms of exportation of nutrients, for instance. And if we have longer time series, we can also relate to extreme events like El Niño, La Niña, and other heavy rainfall episodes, for instance. So another important research line is regarding to water quality in rivers. in one of those meetings, in one of these symposiums, I was talking to York, and he realized that I had some disdrometers in our sites. And he was saying, do you know that these can be used to calibrate radars? And I said, yeah, I know, because probably this is something I would like to have in the future. And at that time, he was writing a transfer project to implement radars in Ecuador. And we said, why not to put one in Cuenca? And thanks to that conversation, now we have a radar, the CAX, that is working in the headwaters, installing the headwaters of the Tomebamba River, and with which we have now a completely different picture of hydrometeorology. That is my main research line. So before I was learning from rainfall from a single rain gauge, but now we have maps of rainfall every 5 minutes, so we can really see the storm, how the storm is moving, how intense it is. So really, it as a game changer to understand hydrometeorology. A couple of people have already done their PhDs using this sensor, and tomorrow we are going to have a talk by Joanna Orellana, who was the first PhD student who calibrated the radar and now is in charge of this research line as well. And finally, in terms of restoration, we started at the beginning just understanding how our seeds are working, how the forests are producing seeds, how good the seeds are for, and in which period of the year they are good. And after a couple of years, we have finally this observatory for restoration, with which we expect now not only to understand how the forest is growing and all the changes that can happen, but also to inform farmers how to grow forests and how to reforest places that were already deforested completely. So Jimena Palomeque, she did her PhD also in the research station, and later on she joined us in University of Cuenca, and now she's leading this research line. And finally, there was another research line that we wanted to implement. It was micrometeorology, because we were worried about the paramos. Everyone thinks it's a sink of carbon, but we didn't know really. And we were able to buy these equipments in Edith Kovarian's tower, with which you can measure CO2 emissions, among other parameters. And Galo Carrillo, there's a professor in Cuenca, was in charge of this sensor, and of course we needed expertise from abroad to use it, because it's a complex piece of equipment. And he did his PhD also in Marburg with Professor Bendix, and now we have a new research line in micrometeorology. Now we have a new PhD student that is also here, Cindy. So again, we were able to open a new field of study thanks to this cooperation. So those were the developments that were happening together between German universities and our university. So in 2014, 13, more or less, we already realized that we were going too fast, and the authorities in the university also realized that the structure was not enough to support all the research that we were doing. So we created the first research department of the university. So the University Council approved all the regulations after a couple of years of trying to convince them. And the first department of the university was approved in 2013. And that's the Department of Water Resources and Environmental Sciences. And I was appointed as the first head of the department. And I knew with this implementation university, we could really push forward. And the first thing what we did is to create graduate programs, because so far we hadn't had a master program or a PhD program. And what we created is one master program in hydrology with a specialization in ecohydrology. It's a research-oriented master. And we also created a doctoral program in water resources at the beginning, and in the second phase, the program was grown into a renewable natural resources program, in which we are integrating also biodiversity and renewable energies into the field of specialization. Something that is really interesting from this doctoral program is that it's an inter-university program. So it's not only from University of Cuenca, but it's in collaboration with University of Azuay, because we have different expertises, different strengths, and we wanted to combine that different fields of expertise. And for instance, in Cuenca, we don't have University of Cuenca, a school of biology. UDA is very strong on that, and we were strong in water, so we could really join efforts and to have this doctoral program that is, the first doctoral program started in 2015, And I think from 2020 we have this new doctoral program in renewable natural resources. And of course, now we have new generations year after year of new students working in these programs, doing their PhDs, doing their masters. Some of them in our program, some of them still in German universities, in case we don't have all the fields of specialization, and also in other universities, for instance in Belgium as well, that we have a strong cooperation. So the situation has changed dramatically in terms of how can we prepare the new generations of scientists. Then we also realized that these programs are not enough, because we also need to reach the society, the farmers, or for instance in irrigation systems, also to the associations. And now outreach programs are also an integral part of our development. So we try to work from the beginning with farmers, with in terms of, for instance, agricultural production, but also in terms of restoration, in terms of also water, drinking water. So this cooperation is reaching places that we didn't envisage before. So now I go back to the first slide where we started, and just trying to think how we have changed in these 2 decades. So in terms of human capital, now we have a full department with a professor with a PhD degree, everyone with a given research line, pushing forward, but also working together, because the moment that we decided to have these observatories, it was also an opportunity to work together and to integrate the disciplines that beforehand were split or were scattered in different places. So there were different sites in which we were doing research, but without cooperation. Now we have a strong research infrastructure, as I have shown you. The internal organization also have changed. Now there are, I think, 9 research departments in the university, and we're still leading the way. And the partnerships have evolved, have grown, are more stronger. What I really appreciate from the partnership with German universities is that this collaboration is horizontal. So in some cases we have partnerships with other universities, but it's more like top-down approach, more like paternalism, in which the university comes, gives you some help, and then withdraws. But in this case, having long-term sites, really it makes possible to have very horizontal collaboration. We have now graduate programs, strong programs. We have changed completely the research culture in our university. Now everyone wants to do research. So what's missing still is funding. So I'm glad that DFG is here, so we can really push forward and try to incentivize Cenecit also to leverage the work that the DFG has been doing. So hopefully in one day we can also get some more funding from our own national institutions. But I was thinking about the impact of all this collaboration, and for me the impact goes beyond the number of papers or the number of people that have graduated. And it's very hard to quantify after looking back and analyzing how things have changed in my university. Really the impact is that now we have a full university, let's say, because it's not only teaching oriented, but we have all the aspects that make a real modern university. So it's difficult to quantify, to put in numbers, but certainly the impact has been enormous. And in my final slide, the future, for sure, I think the partnership is going to grow stronger. Now we have more professors joining us in this collaboration. We have young students finishing their PhDs, going to other universities, and other universities are also now being part of this network. Now we have ex-alumni that is living abroad, in Peru, for instance, and now we're planning to have a research unit combined between Ecuador and Peru. So things are even going beyond the borders of Ecuador. For sure, now we have the chance to develop more relevant projects, because the more we know, the more we can really find solutions for basic problems. So at the beginning we started with a more basic research, fundamental research, but now we have several projects which are more applied research, solving the more pressing issues that are coming from our society. We continue working in our observatories. We hope that they will be operating like forever. So far we have 15 years of 16 years of operation, which already makes a kind of long-term data sets for an observatory. So we are also proud to have that. And of course now we have many more ideas on the projects we need for the future. And of course we want to have them with more local participation from the scratch. So we look also forward to co-creation of knowledge with the communities and with the basic organizations. So I really hope that in the future we will be celebrating 50 or 60 years of partnership with German universities, and I look forward to open more roads or more paths as we have done in the past, because really it has been an experience in which we have built a new university and also new knowledge in this partnership. Muchísimas gracias.
So thank you very much, Rolando, for your talk. It's very impressive what has been developed over the last years. And I guess because of the sake of the time, I guess we definitely already have difficulties with questions. And I hope that this is possible. So after the talks in the lunch break or something, or during the poster, so that we can intensify the discussions. Otherwise, we are running out of time, unfortunately. So with this, I would like to go to our next university, which is cooperating with us. Sorry, I have to look into the program, and of course that is the UTPL, our host, and Juan Pablo Suarez will talk about their visions and the collaborations in this important topic, biodiversity, environmental change.
So thank you for the invitation to this symposium. For me, it will be a pleasure to share a more personal view, personal experience of this successful cooperation during all these years with DFG groups and all the work that we made together. So since the beginning, we had the chance to exchange and to get a lot of good experience with colleagues. At this time, the professor from Germany, with Professor Kotke and Professor Oberwinkler also, and Iber Langer from Kassel University. And this was for us the beginning of many things. So the beginning of new topics, the beginning of new possibilities to develop biology, and mostly macrobiology, molecular biology here at the university. And I had a chance to work during all this time in mycorrhiza. That is a very interesting system because probably most of you knows, but mycorrhiza is a relation between plants and fungi that are mostly in the soil, and it's a relation where both are exchanging nutrients, and is a mutualistic symbiotic relationship. And this mycorrhizal relationship is very common for plants, for land plants, it's very common for roots. You can even say in some way that plants, they don't have roots, they have mycorrhiza, because always, in most of the cases, in the roots are the fungi related, and this fungi is helping the plant to get a lot of nutrients and also to support stress, hydric stress, and many conditions. So it's a real well-established relation between plants and fungi and soil fungi. And there are different kinds of mycorrhiza. Based in the kind of the relation, there are different names for this. And we chose orchid mycorrhiza. And we chose this because it was a very interesting system in the case of our tropical forest. And this is a a kind of endomycorrhiza, so these are the roots of the orchids, and you can see here, these coils are fungi, these blue coils are fungi that are within the cells, and they have the chance to exchange nutrients, and so it's very important for the orchid because the orchid needs, in the beginning, needs some carbon coming from the fungi, and then there is a reciprocal movement from in the other direction. And why is important the orchids and the mycorrhiza here in Ecuador? It's very important because we have more than 4,000 orchid species here. But all orchids needs a fungi to germinate. So all orchid needs to beginning just to produce the small and tiny seeds that are without reserves, are very tiny. So they need at the beginning to germinate, just be related to one specific fungi. So our journey begins with many questions, and the first question at that time was which mycorrhizal fungi are associated with epiphytic orchids, because at that time it was known that terrestrial orchids were associated with fungi, but was completely unknown what was the situation of the epiphytic orchids. And also connected with the first, if these fungi are similar to the knowledge that was known about the terrestrial temperate orchids. So to start this, we decided to focus in 4 very frequent orchids in the RBSF, and you can see here the 4 orchid species, and based on the methods that was available at that time, so we try to understand the situation. So, and we try to get information from many sources. So the basic one is just to look at the roots by microscopy. So are the roots colonized by fungi? Of course, you know that are colonized, but you cannot have an information about the identity of the fungi, but this, just that is colonized. Then was the chance in the cooperation with University of Tübingen in the frame of the research unit, was possible to do some electron microscopy to look some special features in the fungi to know an idea, to have an idea about the identity, but a general idea. Then another possibility was to try to culture these fungi and try to get some information from these cultures. And also the main sources of information, the most of the information comes from molecular biology through DNA barcoding and molecular phylogenetics to get an idea about the identity of these fungi based on molecular tools. But then also we search for the fungi, for the species in the forest that are forming these fruiting bodies, and also try to get some morphological data from the fungi. And finally, we tried many experiments also to see how works this germination in situ. So most of the information that we got was from molecular methods and was a lot of important data, but then comes another question. So how to define fungal species based on this information that we got from DNA, from specific regions that we decide that are the regions that were more used for this delimitation, but anyway, always was a bit unclear how to exactly define these species. Okay, so I will try to present you some questions and then the answer that we got. Just for timing concern, it's only 100 questions, so don't worry about the time. No, are few questions, don't worry. So regarding the first study, so we got some information about the different fungal groups, and this was a group that is called Tulasnelales and Sebacinales. We found these molecular definitions of species. So we found 13 for these Tulasnelales, and we found 80 for this Serendipitaceae. And we found that many of the orchids share the same fungi, but the sampling was too small to conclude more about this. And about the relation between the terrestrial and the epiphytic, at this time was completely unclear. So we don't have enough information to conclude about this. And how can fungal species be delimited also was at this point not so clear. So then, as we was taking part in a bigger project, the idea was to look for the possibilities of common guilds between different plant groups, not only orchids, but also considering other groups, and this was more or less the general picture. So the idea was to see if mycorrhizal fungi that are associated to different species, for example, with trees, also with epiphytic orchids, with ericaceae, and also with the liverworts, to see if they are sharing between these different groups of plants that are sharing the same fungi, and then to have the idea that it's a network in connection in the forest. So to test this, we again look at the molecular data, getting information directly from the roots, and we found that that in the case of ericaceae and orchidaceae did not share otus. So the otus or the species, the fungal species, were shared within the plant family, but not between or among the different plant families, in this case between ericaceae and orchidaceae. So this was the answer, and then as we are working in a system that is a well-known system that is with a lot of diversity, the idea also was to try to understand how this network works and what is the effect if some key microbiomes are lost, and how this works and how is the effect of this in the interaction network. So the idea or the hypothesis were two. So this will be a nested interaction network. So you have here many orchid species, and as I'll tell you before, in Ecuador we have 4,000, even more, but at least 4,000 orchid species. And then here in these black dots are the fungi. And if it's nested, so we will expect that some fungi are key and are connected with many orchids. But another possibility will be that a modular system where every orchid has a specific set of fungi that is related. But this, based on the huge biodiversity here of orchids, then this scenario was not so expected. So finally, this was connected with this sixth question. So, do orchid mycorrhizal fungi interactions promote the coexistence of multiple orchid species? And to try to understand this, we performed these experiments and this analysis, and through this plot for terrestrial orchids, and also this linear sampling in the branch of the root, in the branch of the tree, sorry. And we collect in total 114 orchid individuals across different habitats, across pristine forests, regenerating forests, and landslides, so in the area of San Francisco. And finally, we got a clear picture that the interaction network was nested. So you can find here, there are some fungi that are very important for the network. So here are the orchid species, and here are the fungal in this site. And you can see that there are some fungal partners, some mycorrhizal fungal partners that are connected with most of the orchids, and these are very key components of this network. And if you lose one of these key partners of the network, then the network is not stable anymore. And what about the question 2 that we had? So at this time, it was also not possible to really differentiate the fungal partners between epiphytic and terrestrial orchid, and this is why, and this is also because the the terrestrial system in most of the cases was not a real terrestrial one because orchid was growing in humus layer, and this habitat was quite similar also to the epiphytic in some way. So, but at this point with us, the answer was not so clear. We found, so the record that we found of diversity of the different fungi was increasing in time. So now with bigger sampling, we found 29 otus of Tulasnelaceae, Serendipitaceae 12, and we found something that was completely unexpected. We found a new group of fungi that was forming mycorrhizas with orchids, and this is called Atracteliales. And what about the orchids promote the coexistence of orchid species? This was not clear still at the moment. So we have the chance to publish this new group. This was very important for this topic, a new group of fungal group forming mycorrhiza with orchids. At this time, the group also of mycorrhiza here and microbiology here at UTPL was growing with new colleagues that made PhDs also and take part in different projects. And here is also Professor Kotke. And we continue with also coming back some questions that was unable to answer at that time. And also there was a change in the technology, and we had the chance to collect more samples, to get more information, and just try to understand in a better way the system. And about the delimitation of species, we had also the chance to collect material of fruiting bodies of the fungi and try to delimitate a threshold to use it based on morphology, also to try to delimitate the molecular definition of the species. And this was very, very useful for this field, but also was a very good opportunity to discover something new species. In this case, we found a new species of this group that we call Tulasnella andina. This was also a cooperation with Frankfurt University con Meike Piepenbrink. And what about try to understand in the whole picture? So how all these factors or drivers are working together? And this was in the frame of respect that we have the chance to have a bigger sampling effort, and we consider an elevation gradient, we consider different sites, and we consider also several orchid species. So finally, we had the chance to collect approximately 700 individuals, and to get a better picture of this. And the analysis were done by Illumina sequencing, and with new technologies, we have the chance to get a lot of information. So just like a brief summary, because many questions are still open, but just a summary. From this bigger study, we got really interesting results. So we found in the system, we found nearly 5,000 fungal species definition by molecular tools related to the orchids. Not only mycorrhiza, but in general, root-associated fungal. This is really a huge number, and within this number, we found 271 species that are orchid mycorrhiza. This is also a huge number. So there is not any previous report of such a huge diversity associated of fungi associated to orchids. Also, we found a pattern that until this study was not possible to see. We found this pattern that the richness of these fungal partners peak at the mid elevation and decline at the high elevation. We found that this works, the community structure was a multi-scale dynamic. So it's influenced by elevation, is influenced by site, and is influenced by host orchid species. So in some way, it's all the drivers are acting at the same time. But we found a core of mycorrhizal species that are across all these drivers. So this core works independently of all these drivers, independent of elevation, the site, and the host species. There is a persistent core. And microhabitat heterogeneity contribute at this differentiation on each side. And this is also probably connected with niche differentiation and also how this huge diversity of different orchid species are coexisting. So there are some information. I'm not going in detail for time. And finally, just an overview. So now our group of microbial is called Microbial System Ecology and Evolution. Is growing. We have a lot of colleagues working there in different focus, and all this actual development is possible just for this cooperation that maintained during all this time and all the ideas, the capacity, even the inspiration that we exchange with this during these years. And our group is focused in microbial ecology. We have an interdisciplinary approach, and we want to achieve a holistic understanding of microbial interactions, and also we want to develop sustainable applications based on this microbiology. And all this development is possible through a lot of cooperations, of course, University of Tübingen, the DFG unities that I had the chance to take part, also DAD, and other universities also in Belgium, in Spain, also Frankfurt University, and Cenecit also that help us in one of the phase with this finance, also Freie University of Berlin, and many more. So for me, this was a pleasure to share with you this more personal perspective, and just looking forward, I think has been a very successful story, not only from the scientific point of view, as my colleague told before, but also from the point of view of many people had the chance to learn, to interact, and we have the chance to construct a research group that is consolidated and is growing in time. And I am very happy for this, and I hope that this successful history of cooperation maintains in the time, and we can celebrate more years of cooperation in the future. Thank you very much.
So thank you very much, Juan Pablo. Also very impressive what has been developed over the years, and looking into future, that is great. So now we change from Loja again to Cuenca. Our next speaker is Pedro Astoillo from the University of Azuay. There he is.
Thank you very much for this presentation. I'm going to present here an experience in order to improve monitoring small vertebrates in Paramo ecosystem. Basically, I will present two main results, so I will be very brief. So, thank you again. So, why we have to monitor Paramo grassland ecosystem? But probably many reasons. For example, Paramo ecosystem is the major vegetation over 3,000 meters above the sea level. As well is an important center of diversity, endemisms, and ecosystem service in particular. So paramo habitats and species are very connected, and it depends or is very related to the ecosystem functionality, which also well represents a high performance of ecosystem service. This part is quite important because I'm going back to this part at the end of the presentation in order to link how animals and habitat should be helpful in order to understand ecosystem service beyond that, the results of a simple monitoring vertebrates. This is the endemic province of Paramo of Northern Andes. There is a many districts. Here is the district of the south center of Ecuador, and it's a distinct endemic center of this province. Within this district, the core area is the Macizo del Cajas Biosphere Reserve. Of course, many endemic organisms, especially plants, but as well as two important animals like frogs and birds are quite important in this area. So we are facing a lot of challenge in order to keep going monitoring efforts along the time. For example, for birds, it's a lot of effort and long time hours in the field for monitoring the bird composition, the bird community. And for frogs, the community is characterized by many critical species with non-resolved taxonomy. So within this framework, we use the surrogate species concept in order to improve the monitoring for birds. What does a surrogate species mean? Well, basically, it's a subset of species of the community which represent the totally characteristics of the community. In this case, it's a subset of species which are endemic, which have high habitat affinity to different paramo habitats, and as well as is threatened species. For frogs, we use the concept of habitat girls, which basically is related organisms such as frogs, which are sharing or occupying the same environmental space, and this can use independent to the full taxonomy result. So for birds, we use 18 surrogate species, and we use climate data from 2005 and 2020 in order to understand the potential distribution of the entire 18 bird species. So we found that an increasing area in 60% in these two intervals of the years. So in blue, you can see many pixels in the south, some on the east, some in the north, with potential distribution is predicted in elevation range between 3,400, 500, 3,600, but with climate we use in 2020, in the green polygons, the birds apparently move higher elevations, and probably that is a reflex and effect of changing the distribution of the paramo bird community. So in order to understand this phenomena should be aligned with the general pattern that some organisms from the lower elevation and moving to or changing data distributions to higher elevations in response to effects of the global change or the climate change. But this distribution is usually associated with a long elevation gradient from, for example, cloud forests, mountain forests, and paramo grasslands and the mountain tops. What we found here is a change in distributions inside the paramo grasslands, in the highest ecosystem in the mountains. So we have to look for different information about to understand this change. And we found there is a slight difference of the rainfall patterns in the Macizo del Cajas area. So here is located the Macizo del Cajas, and the east flank is a combination of bimodal and unimodal pattern of rainfall, and the west flank is mostly bimodal pattern. In other words, the east flank has a little bit more regular precipitation than the west flank, which represent more concentration of grass and humid habitats, and in the west flank probably is drier conditions with promoting more shrubby or semi-open habitats. So we use the current climate variables, and we model again the potential distributions of our 18 bird species. So we found many birds which are adapted to open paramos, humid paramos, are located in the east part of the study area, and a few of them which are adapted to semi-open and shorby paramos are located in the west part of the area. So the 70% of this predicted area, this consolidated map, is located outside of the national system of protected areas. So within this framework, this will be helpful to the managers of natural resource in order to improve monitoring efforts or in order to understand new conservation areas within this study area. So this with birds, but about with frogs. So we used a statistical tool, a linear discrimination analysis, in order to classify 4 different habitat goals associated with affinities to the habitats. So we generate a group of species that are generalists, rocky paramo specialists, grand as druby paramo specialists, in human equation paramo specialists. And we use morphometric variables in order to classify these habitat goals. So many of the species, for example, these Orestes, Pristimantis Orestes group, are located in humid Cushion paramo gulls, or for example, species of Pristimantis Lutzae group are located in grass and shorby habitats. When we explore change in the frog community, we found at the species by species level, the elevation is a good predictor, where Pristimantis Orestes group, for example, is located in the higher elevations, and Pristimantis Lutzae group is located in lower elevations. This phenomenon also is important elevation for habitat gulls approach, where rocky paramo specialists and humid cushion paramo specialists are located in higher elevations, and grass and shorby paramo specialists is located in lower elevation. But in addition, this habitat goal was more sensitive to the component of disturbance of the habitat. So here, this is the component of disturbance of paramo, and some species within some transects are increasing or more prevalent with increasing the disturbance of the paramo. In the opposite side, for example, is locating more specialized organisms such as rocky paramo specialists. We are more sensitive to paramo disturbance. So definitely our habitat goal is more sensitive for conservation implications than the approach of a species by species manner. When we modeled the abundance of these habitat goals, we found that all the specialized habitats goals are negatively influenced by the component of paramo disturbance, and the more specialist groups like a rocky paramo specialist and humid cushion paramo specialists are located in higher elevations, are increasing the abundance in higher elevations, and grass and shorby paramo specialists are decreasing in higher elevation, which means are more abundant in lower elevations. So these two main results can tell you a nice story with hopefully nice implications. More natural paramo habitats are generally limited to the protected areas, to the national system of protected areas. So using surrogate species, we identify these habitats by the distribution of specialized birds. Like, for example, this grass and humid paramo is located in the east, and this pair of birds, for example, represent a more available habitat of semi-open paramo, shorby paramo in the west flank. As well as the habitat goals say us a nice story with species adapted to rocky and humid habitats are in higher elevations, and probably generalists are located where more disturbed habitats, and birds, frogs specialized to grass and shorby habitats are located at lower elevations. So, beyond this information, we can find also that the disturbance is really important in the paramo habitats. So, many researchers have nice studies about the disturbance from effects of rows, exotic plants, plant plantations, fires, agricultural fires, cattle grazing. So more recently, we found a nice information that probably we combine with these two results. So this is a change in the composition of woody plants in the Páramo. Again, here we are a disturbance habitat component of the Páramo, and some shrubby species are increasing the abundance along this gradient. The disturbance is quite complex here. It's páramos like are burning and burning and burning with cattle grazing, and probably after such an interval of time is abandoned and promote more woody encouragement. So it's kind of a replacement between grass by shrubby plants. So these kind of plants are mostly abundant in this part of disturbed páramos. In this context, probably the páramo habitats and the specialized species, probably the grass and more humid, are losing, which definitely we have to think about that if the ecosystem service of these particular habitats are showing some alterations. Probably monitoring small vertebrae is a first thing in order to understand change in the habitat and then try to deeply connect to the ecosystem service such as hydrological regulation. So more humid grass and páramos are probably replacing by these semi-open and shrubby páramos. So the question is, we have to conduct the restoration with this kind of flowers, with this kind of shrubs, which produce flowers the entire year. So this is a picture of how disturbed páramo looks with shrubby plants. This a páramo near to the road with a lot of effects of cattle grazing, with many plants is characterized by produce flowers the entire year. If the disturbance promotes this effect, if you promote a restoration based on this kind of plants, probably we are facing an acceleration of this encouraged woody plants. So probably we are taking these more natural plants, grass and more humid, increasing the abundance in scenarios of disturbance and restoration with promoting this semi-open shrubby páramo. And if we persist, probably, I don't know, we lost the first one, with consequence in ecosystem service. So thank you very much for the opportunity. Thank you very much for the colleagues of the DFG, in particular Professor Farbing and Professor Bendix. This actually monitoring was started with Professor Farbing in the 2012, and now we try to keep going this monitoring with a huge support of the Universidad de la SOAI. So thank you very much, Professor Anzaloni, for the continued support of our research.
No, yeah, okay. Thank you, Peter, for this very nice talk about what you are doing at UDA and the biological domain. And now we come to the last of our cooperating universities, and that is, I guess, the rector himself, Nikolai Aguirre. There is Nikolai. So we are very happy that you talk about your visions of the UNL.
Dr. Christina Peters, Director of the South American Office of the German Research Foundation, Professor Nina Farming and George Bendix, speakers for the RESPECT program, dear authorities of the Consortium of German and Ecuadorian universities, dear Ecuadorian and German researchers who have been an active part of the scientific platform, good morning to everyone. To speak on the scope of research cooperation between the universities of Germany and Ecuador is to invoke memory of the most significant research experience we have had in our region and Ecuador. The experiences have transcendental the institutions share as beyond contribution to the support of the UNL. They have also provided the opportunity to voice our local human talent. There have been dozens of the university of the UNL researchers we have enhanced their research capacities. Today, we stand as an example of professional development that allows us not only consolidate ourselves as researchers, but also as management and principal authorities of the first University of Southern Ecuador. Furthermore, we learning that science is not made without budget alone. It is made with people, with mutual trust, overcoming the barriers of the language and culture. Thank you, German and Ecuadorian colleagues, for that constant motivation over the last 30 years. The primary milestone we have experienced that being maintained a continuous research project for the last 3 decades in the Ecuadorian neotropical, specifically in the Andean gradient of the South Ecuador. This Andean gradient is one of the most complex and interesting natural laboratories in the world. As it can be observed, your living laboratory is located in one of the most critical biodiversity hotspots on the planet, situated in the transition between the Andes and the Amazon. Moreover, it includes a unique diversity from mangroves, dry forests, and cloud forests to paramo. This diversity allows to understanding statistical rarity and natural variability in all its expressions. The Universidad Nacional de Loja has been a strategic partner for the consortium. Initially, we participate in a process like a facilitator role. I remember that around the years 1997, together with a team of botanic and ecologists from the UNL, we accompanied a team of German scientists. Various exploratory travel were conducted throughout the Provincia de Loja and Zamora Chinchipe. These expeditions aims to find plot sites to implement the scientific station and conduct to do the first investigation. Later, our role involved and we become a strategic scientific partner, co-leader the generation of knowledge in the south of Ecuador. In summary, 30 years ago, the UNL opened the doors of this territory. Today, the UNL co-leads science, contributing technology, specialized human talent, and first-rate infrastructure. We now have more than 30 research projects on sustainability topics, 20 community support projects, more than 20 sustainable practice on university campus, etc. During these 30 years, the UNL has achieved informalized science. We have achieved these through the support of these centers, institutes, laboratories, urban and postgraduate programs to provide continued support to the research. We concurrently have 7 research centers, 5 experimental stations, and 60 master degree programs, and 50 careers. The existence of the team of researchers motivates us to respond to future of science has also allowed for the formalize the science. This level of scientific maturity is what enables the UNL to face current and future research and for the changes. UNL research has also focused on specific fields that are closely linked to the development of the South Ecuador. Consequently, sustainable agriculture has been a core. The UNL, for years in this field, we have generated knowledge in 2 fundamental areas: comprehensive studies of the region soils and the sustainable production of coffee. Another field where we have made notable progress is biodiversity and climate change. In this area, we have developed dozens of projects relating to water management, ecosystem services, landscapes restoration, fire management, and biogeography, amongst others. One of the UNL strengths is the scientific capacity to study and catalog the flora. This is due to its Loja herbarium and botanical garden, both with the over 70 years of the existence. Furthermore, the existence of the consolidated team of scientists are a score strength too. Based on the capacity, the UNL has documented the floristic diversity on the macro ecosystem in South Ecuador. As can be observed in the graph, the recorded flora reaches near the 5,000 species. These data have been documented through various projects, developments by the university, involved both institutional initiative and national and international cooperation. La Universidad Nacional de Loja is an institution that has worked extensively with a strong community to biodiversity conversions. For example, we have 2023, it is declared with an institution vision like become to Sustainable University of Ecuador. Among these strategies implemented and maintained by the UNLR, the first, ex situ conservation, when maintain a collection at more than 1,000 species and the Reinaldo Espinosa Botanical Garden and the city, near to city at the Loja, and the collection 120 tropical rainforest species and the El Padni Botanical Garden in Zamora Chinchipe. The other strategy is in situ conservation. We maintain 100 hectares protected areas in the city of Loja, a scientific station at the Padmi, the Zapotepamba Scientific Station, and the El Chilco Dry Forest in Zapotillo. Furthermore, the Herbarium Loja contains more than 50,000 collections, and the Siloteca from the regional regions have more than 20 species and the main forests in Ecuador. These capacities are reflected in the importance of the master. We involve all this capacity to the development master in biodiversity and climate change. In this moment, this is development. The Reinaldo Espinosa Herbarium in its long institution trajectory has developed various studies in different plants taxonomic group. Among these studies, the discovered and described as new species for the science, I now present the last 5 species discovered by the herbarium researchers. You can see Guzmania tapilachacensis. In conjunction with other associated research, the description of new species from Valia. The third species is also a new record. The name is Cecropia, and the fourth species in the family in the Cecropia, the Bromeliaceae, Tyransia loxensis, and the last new species is Racinea jaramilloi. Ecological restoration has been a field extensively studied at the UNL. We have spent more than two decades researching in the fundamental role in the recovery of essential ecosystem services and biodiversity in the main ecosystem of Sur Ecuador, particularly in areas degraded and light cover changed to pasture and fires. We have installed more than 50 permanent plots for constant monitoring in the dry forests and the forests, paramo, and tropical humid forests. Efforts have also been oriented towards understanding natural regeneration process, ecological dynamics, carbon storage, water regulation, the identification of species with high resilience, and promoting the recovery of native plants. A significant effort by the UNL to integrate scientific knowledge with adaptive management approach has been the design and implementation of the master, the name is Master in Tropical Landscapes Restoration. Studies in wood technology have seen significant growth at the UNL. The dendrochronology at wood anatomy laboratories have been created where basic research is being conducted. Subsequently, based on the knowledge generated by the research, arboreae, which more than 6,000 registered trees have been developed. This allows for the organization and sharing of information on timber species and support the management of urban trees in cities. This last process has involved in Info Madera CC, an automatic wood identification system through a mobile application using artificial intelligence. All these progress has been possible thanks you for the integration between engineering careers and the research and innovation centers of the UNL and German universities. Regarding the study of water management resorts, the UNL, through the Center for Tropical Environment and Biodiversity Research, CTAP, is developing 2 research programs. The first, the name is Cuidar, an interinstitutional program launched in 2002 to support cross-border water governance through coordinator and collaboration at multiple levels and among multiple actors. The second is nature-based solutions impact evaluation. This program aims to evaluate rural and water security in the south the Amazon of Ecuador. This is done by integrating hydrological and socioeconomic information to scale and replicates intervention in the coast border headwaters of the Mayo Chinchipe watershed. The complement and strengthen the capabilities of Northern Ecuador and Peru, the master program in watershed in water management and diplomacy was implemented in the last months. To answer the question, what are the main challenges identified in relation to coffee farming? We are investigating the various factors causing critical environment stress to this crop. These factors include deforestation, forest fire, and prolonged droughts, which cause soil erosion, nutrients depletion, and the significant decrease in crop productivity. As a strategy to address these challenges is in coffee cultivation, the UNL designed a research program that includes 7 projects. The concurrent scope of work includes characterization of coffee germplasm, plant nutrition, dynamics of carbon sequestration in agroforestry, and systems mix and other natural systems, and for implementation on soil conservation practices. In summary, the program seeks to cultivate coffee under sustainability approach. With the objective to implementing a geoportal for the management of Ecuadorian forest species distribution models and providing open access to relate geospatial data as a key input for the formulation of conservation policies, biodiversity protection strategies, and landscape restoration planning. Species distribution models emerge as a fundamental tools for understanding where species are located, predicting habitat loss, and identify priority areas for conservation and sustainable management and landscape restoration. By integrating ecological and environmental data, the models provide the spatial evidence necessary to design adaptive strategies for address Ecuador forests and solvent the crisis and safeguard its biodiversity for the future generations. The seed planted a decade ago with various corporations, including, of course, the University of Germany, has germinated into robust networks that today include other universities from Europe, North America, and Latin America, as well as international ONG and above and national and international networks. This has not only allowed us to participate in research projects, but also to generate a scientific capacity that supports the production of vital information for decision making. The work of the UNL is to reaffirm that the UNL will continue to promote research with an impact of society in South Ecuador. Looking forward at the UNL has made out roadmap centered on science and technology to address global challenges. Our strategy is divided in 2 fundamental pillars: biodiversity documentation and landscape restoration. From a socioeconomic perspective, we promote sustainable agriculture and early warning systems for natural disaster. Through emerging technologies such as artificial intelligence, big data, and low-cost sensor, we optimize smart monitoring. Finally, we prioritize the improvement of our scientific infrastructure and the support of social communication of knowledge to transform our regions. On the other hand, it's vital to emphasize the importance of training new generation of young Ecuadorian researchers. with which to continue generating research to produce scientific knowledge. In other words, we need to educate the generation of research who will take the lead in future scientific endeavors. We are convinced that your intervention will constitute a significant contribution to enrichment the disciplinary dialogue and the construction of knowledge that Ecuador and Germany have built during these three decades with scientific rigor and deep territorial sensitivity. Finally, the biodiversity on the Andes recognizes no borders, and your sciences must know either. And my congratulations for these 30 years of global cooperation to save the ecosystem that sustain the life, and for 30 years more of working together for neotropical ecosystem. Thank you very much.
Yes, thank you very much. So it was very impressive also here to see how the UNL was developing also under your guidance. So that's also your work you have done. And I guess we are now at the end of the presentations of our collaborating universities. And we have seen that they all have made some compartments, components of our interdisciplinary research, which is very important and which we see in the visions will maybe also very important in the next 30 years, I would say. We have heard that. Now we had a talk of another cooperation partner, that is Diego Inclán from the National Institute of Biodiversity, but I don't see him so far. It looks like that he couldn't make it. Diego, I don't see you. No. So just a few words. INABIO is a very important partner. National Institute of Biodiversity belongs to the Ministry of Ambiente, and that was very interesting because when we started to have this co-funding with the platform project, CENICIT always said, yeah, we need something, we need a research institute which is devoted to biodiversity, which then can pipe the money to the contributing Ecuadorian universities. Yeah, but we don't have it. And we already said, yeah, you need a National Institute of Biodiversity, and some years later it was getting reality and was one of our very important partner, and is one of our very important partner in respect. So unfortunately, Diego couldn't do it, made it to Loja, and so therefore we can come to the next and the last talk of this session. As we have already said, NCI, our 30 years reliable partner, and I'm very eager to hear what Matt is reporting about NCI, what we have done, and what your vision is for the next years.
Thank you, Jörg. I'm in the dangerous position of being the one person standing between you and eating lunch, so bear with me. I'm fast. So again, I saw many of you in the morning. My name is Matt Clark, and I'm the Director of Nature and Culture International. I am going to be talking about two basic things during my talk. The first is highlighting the benefits of the partnership between NCI and the Ecuadorian-German research program. And then secondly, I'm going to be highlighting the importance of the subnational protected areas in Ecuador for biodiversity conservation. I got to put my glasses on here. So Dr. Bendix shared some of these statistics this morning about the achievements occurred over the last 30 years. They're very impressive. More than 800 scientific publications, More than 200 institutions participating in some ways from 15 different countries. 100 new species described, species new to science, and 384 dissertations written and published. 207 of those by German researchers, 122 by Ecuadorians, 55 from other countries. And 44 of those are postdocs, and 137 PhDs, and then 207 masters and bachelors of science. So amazing, amazing statistics that you all should feel very proud of. So I wanted to highlight how this research program has, oh, thank you, a little scratchy in the throat. How this research program has benefited our organization, Nature and Culture, which is a conservation organization. So as we shared this morning, we were established at the San Francisco Science Station, thanks to the support of the German program. Before we were actually Nature and Culture, our name was the Fundación Científica San Francisco. So the Science Station is our origin story. And the reason that we're celebrating 30 years now is that the cornerstone for that was laid 30 years ago. Our relationship with the Ecuadorian and German research program has enabled us as an institution to strengthen our partnerships with other research and academic organizations, not just those that are part of this consortium, and has made us a stronger conservation organization. The program has really enhanced our visibility and our recognition, both at national levels and international levels, and has produced strong science that supports the funding proposals that we submit. So in a very concrete way, it has helped us bring in the resources, the funding, to do the conservation work that we do, and that's incredibly important for us. And then finally, the research from the Science Station and by the program complements. We 3 years ago started our own monitoring program, which is very complementary to the research that's done by this program. And the program has provided data that's fundamental to the work that we do with restoration, particularly of the potable watersheds in southern Ecuador that are really important, including for the water that we used to brush our teeth this morning with, for example. So this slide demonstrates how subnational protected areas contribute to Ecuador's 30 by 30 goals. The goals that were established under the Global Biodiversity Framework in Montreal in 2022. So I'll explain the slide briefly. 18% of what are called the SNAP, which is part of the National System of Protected Areas. So national protected areas cover 19% of Ecuador's total land area. 18% of those are what are in the SNAP system or the national system, and then another 1% are what are in a new conservation figure, the National Hydric Protected Areas system. So a total of 19% in national protected areas. And the key takeaway here is that Ecuador doesn't get to 30%, doesn't achieve its 30 by 30 goals only with national protected areas. But the good news is when you add the subnational protected areas, which add sorry, let me look real quick. Another 27%, you get to 46%. So the takeaway here is that those subnational protected areas are absolutely critical for Ecuador to meet its 30 by 30 goals. These subnational protected areas total almost 7 million hectares. Just over 50% of those are in high integrity forests. 79% of that total area overlaps with 68 key biodiversity areas. And there are 560 triggered species And you can see the numbers, 43 plants, 29 fish, 214 amphibians, 94 reptiles, 146 birds, and 34 mammals. So a total of 560 trigger species, which are species of conservation concern, have ranges within the subnational protected areas. This slide, the research that I'm showing here was done by Walter Yetz from Yale University and his team at the Yale Center for Biodiversity and Global Change. So I'm going to give an acknowledgement to him. Walter and his team developed what is called the species protection, I'm going to take a drink of water. The Species Protection Index, which measures how well protected areas in a certain geography conserve the habitats, in this case of terrestrial vertebrate species there. In Ecuador's case, they determined that there were almost 3,000 possible vertebrate species. The actual number, 2,961 possible vertebrate species based on known ranges. And what they found was that the subnational areas increase Ecuador's species protection index by 66% when you compare that to national protected areas alone. So they're important, very important for biodiversity protection. There are 5% of species, or 153 of that, almost 3,000, that are only found in subnational protected areas. And then 35 species completely meet their SPI targets within subnational areas. Another way of demonstrating this importance, this is from Wilderson Medina, who's with Saving Nature, an NGO called Saving Nature. And he used a slightly different total population than the Yale study, but 2,922. And the numbers that are in the center there, by the frog and the lizard and the bird and the sloth, are the percentage of the different taxa that are found within subnational protected areas. So almost 78% or 78% of the amphibian species in Ecuador are found in the subnational protected areas. 82% of lizards or reptiles, 92% of birds, and 92% of mammals. Just briefly, want to highlight what nature and culture has achieved. We, over the last 30 years, have put 5.7 million hectares, into protected status. If you go back and remember that 6.9 million hectares total in the subnational system. So around 80% of the subnational areas, and this is one of the reasons that I'm highlighting today, the importance of the subnational areas, is because Naturaleza y Cultura has assisted putting 80% of the subnational areas by area into conserved status. 59% of those are in high integrity forests, 85% overlapping with key biodiversity areas, more than 2.3 million people benefiting from protection of potable watersheds, 50 indigenous peoples and local communities that we've partnered with, more than 300 partners in general, and 15,000 people that have been trained. And coming to the end and letting you go to lunch. The key takeaways again, subnational protected areas are necessary for Ecuador to meet 30 by 30. That's, if you take away one thing from my talk, that's what I'd like you to take away. And then the second thing is that declaring these protected areas is important, it's necessary, but it's insufficient. We need to make sure that we're doing the work of research and monitoring so that we can adaptively manage these areas, these ecosystems,
We need to build additional capacity and governance so that these protected areas succeed. And we need to make sure that they have enough funding because these areas don't manage themselves. So one of the things we're doing as Nature and Culture is creating sustainable financing mechanisms, whether it's carbon, water, biodiversity funds, to build funding mechanisms so that these areas have the resources that they need for the long term. So with that, I will say thank you, and I'm glad to be here with you all, and thank you for coming, and let's get some lunch.
Thank you very much for this nice talk, and we wish, of course, that you can contribute also your important work for conservation here in Ecuador, many decades, I would say. So we are at the end of this session. I thank all the speakers. That was very insightful what we have heard about that. And as Matt said, we are now going to lunch. And I guess we reconvene here, please, to continue with the next session on 40 minutes after 2 or 10 minutes to 3, I guess, right? Sorry, I have to take my glasses. Okay, yeah, 20 minutes to 3. So, okay, have a good lunch.
"30 years ago, on the Andean slope of Zamora Chinchipe and Loja, a scientific partnership was born, one that would go on to earn international recognition in ecological research, the Program for Research in Tropical Montane Ecology, supported by the German Research Foundation, developed in close collaboration with universities in Germany and Ecuador, and strategic backing from Nature and Culture International. The program set out with a clear and ambitious goal to better understand tropical montane forests, one of the most biodiverse and complex ecosystems on Earth. Its roots trace back to the 1980s and 90s, when growing global interest in tropical forests helped spark a new wave of scientific research. German researchers, after discovering the extraordinary biodiversity of Podocarpus National Park, recognized these Andean gradients as a unique natural laboratory for exploring fundamental questions about biodiversity, ecosystem dynamics, and climate change. It was from that visionary enthusiasm that the San Francisco Scientific Station was established, led by 3 pioneers, Renzo Paladines, Ivan Geiler, Rainer Bussmann, who believed that science, when built through collaboration, can transcend borders and generations. Over the decades, the program, now known as DFG Respect, has produced influential scientific research, trained a new generation of scholars and doctoral candidates in Ecuador and Germany, supported major research initiatives, and strengthened academic and institutional capacity in both countries. As we gather for this commemorative symposium, we celebrate 3 decades of rigorous research, international collaboration, and sustained commitment to conserving the biologically rich landscapes of southern Ecuador. After 30 years, this partnership has produced more than scientific knowledge. It has cultivated a vibrant academic community, planted seeds for the future, and shown that cooperation across nations can become a lasting bridge between knowledge and conservation.